Well, good morning, all, and welcome. I want to say hello to my fellow commissioners, ex officio members, the dedicated staff. I'm looking forward to the opportunity to do this in person, and there's some conversation about August might be the first of those opportunities. So welcome the chance to get back together again. But for the time being, I want to compliment the staff and everyone for pulling together this very important session and thank my colleagues for their attendance. As somebody said earlier today, everybody's busy, but everyone still finds the time to participate in the bipartisan commission. I'm really grateful for that. If the nation can overcome our vaccine hesitancy and get on with what seems to me to be very reasonable public health practices, we can make it happen. We can make a in-person meeting happen and move on. And I'm really looking forward to that. At the front end of this introductory comments, there's a couple of sets of thank yous. First of all, the Hudson Institute. Look, you are our fiscal sponsor, and we are very, very grateful. You've been doing that for quite some time, and we really appreciate this. But in order for us to be as successful as we've been and in the future, we need administrative infrastructure support. To that end, you're always at the ready to help us in that fashion as well. So we tip our hat and say thank you very much to the Hudson Institute. The second group, we don't forget, and but publicly we occasionally don't remind ourselves how generous our benefactors and our donors have been. The commission obviously doesn't cut corners. We work very hard. We're frugal, but we make every penny count. And we decided 7 years ago when Senator Lieberman decided to put this together, we were going to do it. If we're going to do it, we better do it right. And to that end, we needed the support from like-minded sponsors and people who care about biodefense as much as we did. And we found that that mindset among our sponsors. And so we publicly express our gratitude to them as well. Today, we're going to focus on a subject, on a topic of great personal concern of mine, but frankly, it's beyond yours truly. It should be and is a concern of our country, to this panel. Frankly, I think it ought to be a concern to every American, and that's cybersecurity. But in our specific venue, it's cyberbio-security. And I've been privileged to be working in the cyber domain for over a decade, and frankly, it's not a static environment. You watch the threats and the nature of the threat change on a daily basis, as well as the threat actors. And unfortunately, during that same period of time, the biological threats have probably proliferated in the same way. We're just not quite aware of them. But it's interesting, back in 2015, when we put out our first and foundational report, A National Blueprint for Biodefense, we paid some attention to this arena. And we dedicated one of our recommendations to cyberbiosecurity. And to remind everyone, we recognized at that time the need to secure stored pathogen data, to provide the research community with the tools and incentives needed to secure that data, get information about cyber threats to the research and biotechnology communities, and frankly, protect intellectual property, be it with regard to the pathogens themselves or the discoveries related to the creation of antidotes and vaccines, protect that intellectual property from cyber threat as well. We identified those action items, and it's not a matter of we told you so, but we identified those many other action items that were relevant to the COVID-19 crisis in November of 2016. And unfortunately, didn't do very much to address them. And the vulnerabilities that we were worried that existed turned out to be very real during the worst of the COVID-19 pandemic. And the challenges we ran into to run up to producing the needed vaccine. So you would think that after everything that this country and the world's been through, that these issues with regard to cyber biosecurity would no longer be a problem. Just a few weeks ago, we had another ransomware attack, this time on JBS. And I think highly of our commission and our ability to raise awareness of these important biological threats. And COVID-19 certainly dominated our national consciousness all last year. But I'm not sure either of these have raised the awareness as much as the cyber attack, particularly the recent ones. We've heard almost as much concern about the hamburger supply the past week or the fossil fuel supply the past month as we did about toilet paper, masks, and vaccine supplies throughout the past year. And I think it's the general belief of the commission that we can't afford any longer to ignore biological threats. We don't want to be critical, but we did ignore those recommendations, and there have been many lives have lost, and we happen to believe that we could have saved some of them had we been able to embed some of those recommendations over the past 3 or 4 years. Our country also often ignores cyber security threats because, well, we get the threat, we're going to ignore it because all they do is cost us money. And I guess we should conclude that cyber bio threats are one step removed. They're much easier to ignore. But boy, we sure ignore biosecurity threats at our own peril. And that's one of the reasons that the staff has pulled this together. So today we're going to hear about cyber biosecurity threats, wide range of these threats, about the vulnerabilities, and about the challenges associated with those vulnerabilities. But there are opportunities for us to be, as we've done before in the commission, offer problem-solving solutions to these vulnerabilities that we've identified. We need to know where things stand. We're asking our speakers today to be very clear, concise, frank, candid. I think I can speak for all the commissioners, but from our collective experiences with cybersecurity, we're going to go nowhere in addressing this challenge without clarity. And we're going to get that kind of clarity and specificity, I believe, from the group of panelists that we've been able to attract to participate with us today. So with those introductory remarks, it's my great pleasure to call on my friend, my pal, my esteemed colleague and Commissioner Co-Chair, Senator Lieberman, and ask him to make some remarks. Joe?
Thanks, Tom. Thank you very much for being my friend and also for giving an excellent opening statement. You're absolutely right that it's, I suppose, human nature that we avoid threats that when you look back seem like they were pretty obvious. And I think that's one of the roles that our commission has tried to play, to educate people about coming threats. So I appreciate what you said. This is one of those today, the cyber biological threat. And I thought I'd just take a few moments to try to deal with some definitions and examples, because frankly, I myself am not starting out, not that familiar with the terminology. So cyber biology is a word that most people have never heard. So let's begin with the two fields of science that converge into cyber biology. One is obviously biology, which we're all familiar with. The other is a word I had never heard until our executive director, CEO, Dr. George, educated me, which is cyberology. And it's a word that's little used, but it is the accurate term for the study of the internet and its applications. These two sciences, one ancient and the other very modern, biology and cyberology, have now converged into cyber biology. And as in so many advances in science and technology, there are both extraordinary benefits for people, for the world, and there are also risks. Cyber biological developments will undoubtedly already are improving the quality of our lives. Just to give a few examples, the cybernetic exoskeletons that can be incorporated into the bodies of our troops, military troops, to protect them. We can imagine systems for storing data in our DNA and combining organic material with nanites, part of the nano world, and they're like tiny robots. And in fact, the convergence of biology and cyberology is already enabling some extraordinary innovations in medicine, food production, and defense. In some cases, cyberbiology is saving people's lives by producing replacement organs and limbs. But as I said earlier, there also are hostile and negative and destructive uses for this new science. So, for instance, those nanites, those little robots I talked about a little while ago, could be used to defeat the human body's ability to recognize them as foreign objects inside us, allowing them to cause illness and death. Armor could be turned against our troops, with obviously enemy combatants never appearing on a battlefield. Bad actors can take advantage of cybersecurity vulnerabilities in laboratories, for instance, that work with organisms. That can manipulate automated processes, ruin test results, and kill the organisms that we need to study, and eliminate some of the biosecurity and biosafety measures we depend on to keep us safe. In biological data storage sites, bad actors can steal information through cyber biological attacks. They can steal intellectual property. They could destroy years of research and invalidate analytic findings. And in public health systems, they could slow the tracking of infectious diseases through cyber biological means. They could inhibit supplies from getting to where they are most needed in a crisis. And as we've seen in related areas, they could prevent accurate reporting to the public of exactly what's happening. Obviously, we've already seen the consequences of hacking of health insurance databases or the theft of intellectual property from pharmaceutical and biotechnology companies. So we have these extraordinary possibilities from this new science, converged science, and we have these threats as well. And as is usually the case in such situations, we're not going to stop, and we don't want to stop cyber biological developments any more than we could ever stop the union of chemistry and biology, or those sciences and physics. They're inevitable. And so I think inevitably we want to respond in a classic three-part formula, which is the first: we need to support and enable advancements in cyber biology because we want Americans and people throughout the world to benefit from those advances. And also because we want to ensure our national competitiveness in this area, because it's a growing and significant area. So that's first. Second, we obviously want to try to create new security policies to ensure that we find cyber bio threats and associated vulnerabilities quickly and eliminate them. And then third, we need to plan proactively so that we're ready to respond when a cyber bio attack occurs, as it inevitably will. I mean, this is an area that's not mature yet, but coming on quickly, and it really cries out for public-private collaboration to create policy rules that enable cyberbiological advancements, but to see to it that we're all protected as well. So what for me started out when we first started to look at this as science fiction really is quite real, present, important, and in need of interest by both public and private sector leaders, and involvement and oversight as well. So this is a real learning experience. One of the reasons I love this commission, apart from loving our commissioners and staff and ex officios, is that we learn a lot and we have an opportunity and obviously a responsibility to try to warn those in the public and private sector to take action to stop or prepare to respond to the kinds of threats that Tom Ridge referred to. So I look forward to the testimony. We've got some great witnesses. And with that, and thanks, I send it back to you, Governor Ridge.
Well, thank you, Senator. Thank you for your comments. Well, thank you very much. To my colleagues, it's a great pleasure for me to introduce to you and Dr. Jason Matheny. You know, I took a look at Jason, the bio that the team sent to me, and I just have to read it to make sure that my colleagues and those who watch this program, because it's being recorded, understand and appreciate the range of experiences you bring to the conversation that we're having today. At one point in time, Dr. Matheny was the assistant DNI, Director of National Intelligence. He was director of the Intelligence Advanced Research Project Activity Agency. Since then, he's moved into the White House very specifically, and to ensure that the public and private sectors work together to address cyber biosecurity threats and vulnerabilities. But that's the umbrella over the three other responsibilities, the three specific responsibilities he has in the White House. So let me just share them with you, and then we'll get into his testimony. He is currently Deputy Assistant to the President for Technology and National Security. Check. Deputy Director for National Security at the Office of Science and Technology Policy. Check. Coordinator for Technology and National Security at the National Security Council. You weave those three together and you understand how he's in a position to work with the public and the private sector to address the cyber biosecurity concerns that we have today. So Dr. Matheny, one, we're grateful for your appearance, but probably more importantly, grateful for your extraordinary record of public service to this country. We're anxious to hear your words, and we thank you for accepting the invitation to spend some time with us this morning. Dr. Matheny.
Thank you, sir. It's such an honor to be with you and the commission. I am enormously grateful for the work that you all have done in both eliminating the risks that we face and in providing constructive recommendations for how we can address those risks. I'm also grateful to the commission for raising this topic of cyber biosecurity, which I think has been underexplored, but I think the commission was among the first to raise this as a topic all the way back in 2015. I am generally a Debbie Downer on biorisks, but a few things do give me hope. First is your commission doing such thoughtful work, not only on this topic, but also on the Apollo recommendations. A second thing that gives me hope is what I see in this administration, which is unusually focused on both the opportunities and the risks presented by biotechnologies. We'll have what I believe is a historic number of bioscientists in the White House, including the first geneticist serving as the president's science advisor. And with both Eric Lander here and Beth Cameron, who is one of my heroes, I feel more optimism about biosecurity today than I have in a long time. And we've started to make progress. The American Rescue Plan appropriated $10 billion to prepare for future pandemics and other bio risks. And the American Jobs Plan has proposed an additional $30 billion to make revolutionary advances to biopreparedness and to biosecurity, including additional goals related to biosafety that we hope will become intrinsic to the biotechnologies that we develop. We're also working here to ensure that federal infrastructure funding can make major investments in the tools and skills needed for biomanufacturing. This is not only good for the US economically, it's also good for global biosecurity. Because when biomanufacturing is located in the United States and governed by US laws, we can better ensure that safety and security measures, including cyberbiosecurity measures, are baked in from the start rather than patched on afterwards. On cyberbiosecurity, as this audience knows, a large and increasing number of bio-related devices and bio-related data sets are networked, which presents an increasing attack surface. I've been grateful at both OSTP and NSC for a series of briefings that we've been getting on these topics, both from BioBright, Sandia, APL, have briefed us on work that they've done assessing cyber risks to biotech devices and data. I want to summarize some of the recommendations that came from this work. In particular, BioBright offered general recommendations I just want to mention. The first is to train and sensitize biologically oriented staff to have an adversarial or skeptical mindset when reviewing data. And to editorialize a bit on this, I think one of the things that I think resulted in our current cybersecurity approach is that it took us about 20 years to develop the right level of cynicism about the kinds of adversaries that were going to take advantage of vulnerabilities in our networks. And we just can't wait that long to develop the same mindset that we need for cyber biosecurity. A second recommendation is to assess and review digital components involved in biopharma decision-making, especially in laboratories. What are the tools that are being used? How is data integrity guaranteed? A third is not to rely on a particular level of compliant software to provide adequate logs of biopharma operations, but instead to set up tooling to independently track the identity of files in transit, especially when involved in scientific decision-making. And I think the general point here is that we actually need to come up with much better ways of logging and auditing the data that are being used in biotech. In part to verify the integrity of that data, but also in order to understand attacks that might be ongoing or have already occurred. Another recommendation is to consider the impact of even small or overlooked instruments being subverted. A great example is the impact of barcode readers misreading samples. Barcode readers, not the most secure devices, but if you just think about what that would do to the supply chain within a laboratory or a biomanufacturing facility, often you can do a lot of damage just through that vulnerability. I'll mention a couple of other pieces of advice that we're at least contemplating here and thinking about how to bake this into policy. The first is just to ask what actually needs to be networked. Do we really need networked bioreactors? Do we really need DNA synthesizers that are networked, whose operations are networked, as opposed to, for example, having a network connection to check sequences of concern? Second is the network making use of standard cybersecurity practices. As I mentioned, a lot of the existing work has found that existing cybersecurity practices are not yet incorporated into a range of devices and data sets. Oftentimes, we're not using standard encryption. Oftentimes, we're not using two-factor authentication or other modes of verifying identity. A third piece of advice is to consider developing the same infrastructure of ISACs that we have in other industries. And there is an effort to get a bio-ISAC started with some initial membership. A fourth is to secure the data. And I think the Commission's recommendations from back in 2015 hold up well. The first recommendation was to develop and implement a security strategy for stored pathogen data. The second recommendation was to provide the research community with tools and incentives to secure that data. And the third was to develop cyber threat information sharing mechanisms for the pathogen and advanced biotechnology communities. This year, you scored us on progress against those goals, and you rightly gave us poor grades for all three recommendations. I promise that we will try to do better. We're starting a new effort here to look at cyber biosecurity risks and policy options. We are not far enough along for me to be able to spell those out just because they're deliberative. But I want to reach back out to you all again soon to repeat this conversation and for you all to give us an early grade to see at least if we're going in the right direction. I wanted to mention a few other things that I'm personally concerned about. The first is the screening mechanisms that we currently use in DNA synthesis, I think, are insufficient, both in terms of what we screen, and how we secure what we screen against. Right now, the IGSC members, of which probably most of the DNA synthesis that's happening globally is no longer represented as being IGSC members. At least that's our guess based on the amount of growth of DNA synthesis activity in China in particular. But the standard screening protocols apply to sequences that are longer. They use screening techniques that are unlikely to catch genes of concern that might be embedded within larger genomes that are not of concern. They're not likely to pick up on novel genes of concern. And we don't look for split orders, for orders that might be disguised by moving them across multiple orders. So those are vulnerabilities that we should patch. There was also, work in the open to look at ways of getting through traditional screening. There's another vulnerability, though, in this process, which is you're screening against something. And whatever that list of bad sequences or bad genes is, you might not want to be advertising that. Kevin Esfeld and others have been proposing secure methods for screening so that you could have a list of genes or sequences of concern. You could use hashes or homomorphic encryption or other approaches to screen against that without advertising that list to the world. When I was at IARPA, we had a program called FungiCat that developed some tools for screening, both to address some of the vulnerabilities of the screening process that I mentioned, as well as to address the security of the sequence databases. And I'm encouraged to see some of that work has transitioned into industry. A second thing that I'm concerned about on the horizon is the way that advances in AI and other approaches to data science may complicate some of our cyber biosecurity risks. AlphaFold, which was an effort by DeepMind to solve protein folding problems using AI, is, I think, one of the most exciting developments in AI in recent years, and I think suggests the kind of potential that AI has to advance biomedical research. I think it is by far a net positive for the world to apply AI to problems like protein folding. But DeepMind itself was concerned about some of the safety risks that might be introduced by developing those tools, and had its own safety review team develop some guidelines for that work. I think that was responsibly done. And I agree with the conclusions that they reached about AlphaFold in particular. But I do think we will have to think very carefully about the ways in which new sequences, new proteins could be engineered by applications of AI. AI is also going to affect cyber defense and offense, including cyberbiosecurity. One of my colleagues at OSTP, Ben Buchanan, is one of the world's experts on how AI will affect both cyber defense and cyber offense. Fortunately, it looks like in the near term, at least, there will be an asymmetric benefit to cyber defense versus cyber offense. So using, for example, AI to detect anomalies on networks, using it to better characterize threats much faster than traditional cybersecurity techniques. So I'm hopeful that the application of AI can also improve cyber biosecurity. I know that one of the other questions from the commission is what considerations should be given to cyber biosecurity and an Apollo program for biodefense. I would recommend a central consideration in that the number of networked devices and data sets in biotech is only going to grow. So we need to make sure that the recommendations that you all have made for an Apollo program are future-proof, that they will hold up to the increased digitization of data sets and devices for the future. And on that, I'm looking forward to the Q&A. I'm also just mindful of how forward-looking you all have been about the risks and our need to address them, not in a piecemeal way, but in a strategic way. So I'm just deeply grateful for this opportunity to talk, and I'm also looking forward for the conversations that will follow. Back over to you.
Well, Dr. Matheny, first of all, we can't thank you enough for your presence today. And I made note of your willingness to return maybe in 6 months to take a look at what's transpired to see whether the grade assessment would be improved. So we accept your offer. I remember when I went into the service, my dad said, be careful, not volunteer for much. You just volunteered, and we accept. Thank you very much. A couple of questions, and my colleagues certainly want to get back to you as well. You talked about the dollars that will be distributed in the bio world and the connection between the research and cybersecurity, but you also were very candid. You still question some of the encryption practices, access protocols, et cetera, et cetera. Is there a mechanism in place that subsequent to or along with the distribution of $30 billion, that there are minimal standards embedded in those practices within these companies to reduce the risk of digital exfiltration of this critical information that they've assembled and the research that they continue to do? Would there be a condition precedent, a cyber condition before you get this? Will somebody be taking a look at the standards of digital standards of security that these companies have embedded in their systems?
Thanks for raising that. I think this is an enormous opportunity for the federal government to think about the leverage in federal procurement and federal contracts and grants to have clauses on security, including cyber biosecurity, but also other measures of biosecurity. And this is something that we're pushing for here and trying to get the agencies on board, because I think we ultimately are going to need to use the purchasing power of the federal government to be making progress on these topics.
I appreciate that. And when you're waving the sum of $30 billion in the air, it does have some leverage. The question is, even if you embed the standards, would there be the capability within the administration writ large to see to it that the standards have been met? I mean, that's a rhetorical question. I think that's just one of the challenges you have. It's one thing for people to check the boxes on the application for the funding. It's another thing for the government to come in and oversee this. But you've raised it, and we're grateful that you have. A quick question with regard to the AI-enabled biotech threats. There's some conversation that the what do they call it? Gain of function research might have been going on in Wuhan, and there may have been some alteration of the virus. There's a lot of speculation, and time will tell. But there's a lot of people that view that as one of the most critical, almost existential threats to this country. You are familiar with GenBank?
Yes, I am.
Do you know, they are the leading U.S. genetic database. Has anybody within the administration or you worked with them to ensure that their cyber practices and cybersecurity protocols are at the highest standards?
I don't know, but I can answer that question if you give me a week. Then I can come back for an early grade report.
Well, and I appreciate that, because I think there's some adversaries out there. I mean, we know what they're doing overseas, and we know what the Chinese are doing with regard to trying to get as much data, DNA data globally, and having that information and understanding that that's a very significant piece of information about Americans writ large. We want to make sure that we mitigate that risk of cyber attack as effectively as we can. So I will defer to you. And again, thank you so much for your effort, and turn over to my colleague, Senator Lieberman.
Thanks, Governor Ridge. Dr. Matheny, thanks very much for your service, and thanks for the help that you gave our commission in the preparation of the Apollo program.
Oh yeah,
for
yeah.
Biodefense. Yeah, which we issued in January of this year. And thanks for being with us today, and for your opening testimony. So in the good old days when I was in the Senate and people like Governor Ridge were testifying before us as the Secretary of Homeland Security, we would say, Secretary, what threat keeps you up most at night? So in this field of cyber biological threats, which is still probably a puzzle to not only us, but though we're learning, but certainly to the people who are watching this meeting today, what are the one or two specific cyber bio threats that worry you the most, or to use the expression, keep you up at night?
Thank you, sir. I think the way I got involved in national security is I started out as an epidemiologist working on infectious disease control, think malaria, tuberculosis, HIV. And I was working in India in 2002 when I heard the news that the first virus had been synthesized from scratch, just from its chemical constituents. And it was polio. It was a DARPA-funded project just to see if it could be done. And for me and a lot of my colleagues in India, this was very sobering because a lot of the folks that I had worked with had been part of the smallpox eradication effort. And their first thought was, how long will it be before somebody decides to synthesize smallpox or something worse? And I moved then to work on national security because I was also concerned about synthesis of viruses or modification of viruses that could be worse than what we find in natural outbreaks. So the thing that still keeps me up at night is the synthesis of viruses like smallpox or something worse. And I do worry that we have networked devices that are capable of doing a lot of the work for somebody who is focused on synthesizing pathogens that could be enormously destructive, and doing it in such a way that it would be unattributable.
Yeah.
So that's one thing that worries me. Another thing that worries me is people tampering with bioreactors. Right now, for example, bioreactors that are being used to save hundreds of thousands of lives globally as part of the COVID-19 response. And I think we have seen some worrying cyber activity, as has been publicly reported, in a range of different parts of the vaccine infrastructure. That also worries me. But I think the things that are probably worrying me the most are the threats that I'm not already aware of, and the ones that are over the horizon.
That's pretty sobering stuff, and probably will keep me up at night now. So, to the best of your knowledge, is any first of what an admirable decision you made to move into the security side of this when you learned what was happening. But do you think there's progress being made on the synthesis of other viruses right now?
Well, there's admirable work being done in the biosecurity community, both public and private sector, and I'm deeply grateful to organizations like IGSC that are trying to get industry to adopt screening protocols. But there's also some very challenging trends. One is the market development of desktop DNA synthesizers. Such that the screening may no longer be centralized, which, if DNA synthesis is completely decentralized, it'll be very difficult to detect when somebody is misusing a synthesizer. And then the other trend that I think is worrying is simply the length of genomes that are now capable of being synthesized. I think for me, I had underestimated the cost effectiveness of synthesis of large genomes when horsepox was synthesized de novo a few years ago for roughly $100,000. I thought that was deeply sobering. Right. Given that it's no longer, it's no harder or easier than variola, and it is, at the cost of $100,000, I don't know, 1,000 times cheaper than a nuclear weapons program, and probably just as destructive.
Yeah. So, who are the bad actors here? Who are the adversaries? Are they nation states? Are they terrorist groups? Are they cyber gangs or cyber criminals? Where's the threat going to come from?
Well, I don't think we'll know. And I would add to that list accidents, and including accidents within biological weapons programs. I mean, I think one close call that we had when the Soviets had a very large biological weapons program, there was an accident in 1979 at Sverdlovsk, a release of anthrax because a filter was installed the wrong way. And dozens of people in town died because of this aerosol anthrax. Right. It's really a historical accident, and that lab was working on anthrax and not smallpox, which was being worked on elsewhere in the Soviet program. Next time we might not be so lucky. So we have both intentional attacks to worry about, either by nation states or by individual actors or small groups. But we also have accidents to worry about, and I think that means we have to bake in not only security into our bioinfrastructure, but also safety. Yeah.
So from your answer, I would say that we should assume that certainly nation states and probably smaller organizations, terrorist groups or otherwise, are working on cyber bio threats to us. Is that fair?
I'm limited in what I can say, of course, but I would say that this is something that we should take really seriously as a threat and work on security measures now that we're going to need today and that we'll need going forward.
Okay. Thanks very much. I could go on all morning. You're a great witness. And but I'll yield back to my colleagues. Thank you.
Thank you, sir.
Thank you, Governor. Dr. Matheny, I'd also like to express my gratitude to you and to your team for all that you do. There are so many different facets to this. There are the technological, the biological, and the organizational. And I'd like to focus for a couple of minutes on the organizational in three different contexts. The first is our own government and the concern that we have generally as we look to all of these issues in security about how bifurcated, how splintered, how siloed we are. Give us your view as to the degree to which siloed, splintered, multifaceted agencies working autonomously undermine our ability to collectively address this challenge.
So our decentralization can be both a benefit and a hindrance. And on the benefit column, I'd say that the decentralization means that we're probably not all making the same mistakes at the same time. The differences in viewpoint and judgment, that diversity can be a real advantage. And it means that we're trying a diversity of approaches. It means that we're sustaining a diversity of strategies that hopefully are not all pointing in the wrong direction all at the same time. Simultaneously, it is a challenge to pursue a strategy that we're pretty confident is the right strategy when you have to coordinate it with a half a dozen or more agencies. And that is a challenge that I'm learning in general from the White House, that your ability to get everybody to row in the same direction is imperfect. It relies a lot on negotiation and persuasion, which are tools that you know more about than I do from your career. But I'm learning that in order to make progress on these topics that require an interagency approach, we need to work with the agencies in order to understand their own individual approaches and how to address their own individual needs. I will say, though, that I think that with this leadership at the National Security Council and the Office of Science and Technology Policy, we do have an opportunity to at least come up with a central strategy for how we should pursue biodefense that we can execute, that has clear and measurable goals, and that we hold agencies accountable for those goals, that we don't just sort of treat them as aspirational, but we have 6-month milestones or more frequent where we can say, are we making progress? Because we just don't have the time left to be able to be admiring this problem for another 4 years and not to have made substantial progress. I celebrate every new year relieved that we have not had a major biological accident from either a biological weapons program or from a severe biotech accident. And I think we've been extraordinarily lucky. At some point, our luck is going to run out. And we need to build the biodefenses and the biosecurity measures today that we've needed for the last 10 years, that we need right now, and that we're going to need for the next 10 years. And we can't delay it any longer.
Well, I couldn't agree more emphatically with you and the eloquent way you've just described the circumstances. We have lamented for a long period of time how few resources are dedicated to the whole issue around biosecurity as it relates to, as we compare it to traditional national security questions, both on the coordination side as well as on the resource side. But I'm delighted to see that you've got some confidence that we can address these matters more effectively in a more coordinated way going forward. In the interest of time, let me combine the two other contexts that I wanted to raise organizational issues with you. One has to do with how do you maximize the public-private partnership so required for our success nationally? What are the keys to doing that effectively in your view? And then in the final context is, this is not just a domestic issue, it's an international issue. How is it that we can coordinate effectively internationally to present the kind of coordinated international infrastructure necessary to proactively address these issues going forward? So both on the public-private side and on the international side, I'd love to get your thoughts.
On public-private, I think that Governor Ridge has the right question, which is how are we embedding into our federal procurement that's going out to the private sector the kinds of requirements that we need for biosecurity and biosafety. I do think that is the longest and most powerful lever that the federal government probably has to get change right away. I do think too that there's a lot of goodwill within the biotech community to address these risks, and parts of the community are just looking for guidance. They don't want to start building in, say, DNA sequence screening protocols right now that we're confident are going to be compliant with best practices, and then a year later have to switch them. So they're just looking for information and a direction from government. On international harmonization, equally as important, if not more important, just because the U.S. is going to represent a minority of biotech activity. Whether it's biomanufacturing or DNA synthesis or DNA sequencing, when we're concerned about data security. So finding ways of increasing the likelihood that our allies and partners to start with are going to harmonize these standards through, I think, the international standards organizations as a start. We're having discussions with NIST about this. How can we bake in the standards for biosecurity into the ones that are promulgated internationally? But we also need to be talking with our competitors, countries like China and Russia, about doing the same. I think this is a case of enlightened self-interest because infectious diseases don't recognize borders. So it is in the interests of both the United States and China, for example, to agree to guidance on DNA sequence screening, on cyberbiosecurity measures for laboratory infrastructure, biomanufacturing infrastructure. It's not just a problem in one of our countries, it's a problem for all of our countries.
Well, I couldn't agree more with that as well. Well, we thank you for all of your good work and the leadership you've shown. And Governor, I'll turn it back to you.
Thank you, Tom. Dr. Shalala.
Thank you very much. First, let me say thank you for your service. And I sympathize with your attempt to try to get the agencies of government to both pay attention as well as your attempt to set at least some goals and standards. The most antiquated systems, though, of safety that we have in this country are the places that are heavily funded by the government, the great research universities. And there's always been a movement to do things like cap their indirect costs. You're not going to get them to pay attention without substantial funding on a regular basis to change their behavior and to build these systems. And I was wondering whether how you're thinking about anticipating the future for all of them.
Thanks, Dr. Shalala. I think that there is a need to think about what is the price premium for biosecurity, that we need, and we need to build in then to our grants and contracts, especially for places that are already, having very thin overhead or margins. And this applies, I think, not only to research universities, but also to a fairly competitive commercial sector. We don't want to disadvantage our own companies globally by having them incur costs that are not shared by their competitors. We have a couple of economists here trying to just simply understand the math on this. Like, how much does it cost? What are some creative mechanisms to get for cost sharing or other forms of incentive? And I'm really open to suggestions on this point. And if the commission has done analyses of its own on this, I'd be deeply grateful for them.
I think there are some outside groups that have done some analysis on this, but I appreciate your comments on both the public and the private sector. Let me go back though and ask what kind of conversation, what kind of organization do you have to talk to the other government agencies? And I appreciate the fact that there's a certain point where you want them to develop, to be thinking about these strategies as well with some kind of an overall strategy, because trying to get everybody into the same cookie cutter is almost impossible. So do you have an organization that you're meeting with on a regular basis, or are you having individual discussions? How are you organized?
We had these discussions in the context of both the G7 and the OECD. And I think OECD actually is a pretty natural place for having, because of its breadth, it's just going to cover more of the vendors than the G7. But still, there's a lot of common starting points as opposed to thinking about the UN or the BWC as the convening ground. I think we need to get there. I mean, I think we need this to be something that that is looked at globally. But I think starting with the democratic market economies that are right now doing, the bulk of biomanufacturing, DNA synthesis, it probably makes pretty good sense.
Jim Greenwood, please.
Thank you. And let me also thank you for being with us and for your service. You're just fantastic. So thinking about that hypothetical moment when the bad actor synthesizes a pathogen that is, let's say, an order of magnitude at least both more contagious and more deadly than a COVID-19, which is the sort of dark winter scenario, right? And as I think reading between the lines, you almost think that that's an inevitability, it's just a matter of time. So if we think about how to prevent that moment and minimize the impacts of that moment, there's the upstream side of it. How do we identify the potential bad actors who might have that motive and have a philosophy, if you will, that's suicidal enough that they know they're all going down in the action potentially, and think about access to biobuilding blocks and thinking about access to synthesizers. And then the downstream side of that, which is then what do we do in terms of, quick detection and quick response, and do we have available antivirals, or how long would it take to make a vaccine? All of those, how do we marshal governments and the citizenry? And we've all seen what a debacle COVID-19 has been in many of those regards. My question goes to, and it relates to Senator Daschle's question about the variety of governmental entities engaged who have responsibilities here. And the question is sort of, who's in charge in this administration of thinking about that entire upstream to the terrible moment and downstream what happens afterwards, so that you could behave in an orchestrated way at that moment and before that moment?
Yeah, Beth Cameron is in charge, and I'm deeply grateful that the person who is in charge is Beth Cameron, just because she's so capable and really an extraordinary public servant. I agree completely with what you said before, and I'd even say an order of magnitude greater pandemic threat is probably not the limit compared to COVID-19. COVID-19, as catastrophic as this has been, was a a moderate pandemic, even by historic terms. And if you think about it compared to what we've seen historically, 1918 got a pandemic that is probably 10 times worse by most measures, population adjusted. If you thought about a virus that has 10 times the transmissibility of SARS-CoV-2, a virus like measles, and somewhere between 30 to 100 times the lethality, so somewhere between smallpox and rabies, you're looking at something that could be 3 to 4 times worse than 3 to 4 orders of magnitude worse than what we've seen with COVID. So I do think we're we have a long ways to go to develop the kinds of biodefenses that we need, and I do think ultimately the biodefense that we'll need to substantially shorten the timelines for everything, from first detection of the virus in humans, through better early warning, outbreak detection, metagenomic sequencing of every fever of unknown origin, to better development and characterization of therapeutics, and rapid distribution, and bring all that timeline down by a factor of 10 compared to where we are today.
I'm going to try to squeeze in one quick question and then save time for Ken. Almost 20 years ago, I was chairman of the Oversight Investigation Subcommittee of Energy and Commerce. And right after 9/11, we started looking into cybersecurity risks and bringing in all the federal government agencies and ask them how they were and how they could protect the country from what terrorists might want to do in that regard. And what always seemed to be the case is they would come in, they have plans, and we bring them back 6 months later, and they were always behind. And it was really disheartening. And, the bad guys who are, they don't have to worry about competitive bidding and background checks and procurement and congressional budgeting, and we do. And my question is, are there things that the Congress needs to do to streamline the capacity of the federal government to stay ahead of the game, stay ahead of the bad guys, and move as quickly as one might imagine we should move in this whole world of cyber security?
I do think a big part of this is just getting more members of Congress to understand the threat. I think the commission has done extraordinary work in helping both to raise the visibility of the risks that we face, as well as to provide constructive, realistic recommendations that can be acted on. But I think we need to do more briefings on what we see as the threat, both today and over the horizon. And I think that hopefully will serve to help accelerate everything else that we need in terms of resources. But I think right now there just isn't the degree of understanding of the severity of the threat that we face and just how unprepared we are. In a way, COVID-19 was, again, a relatively moderate demonstration of how vulnerable we are to infectious diseases. And our response to that, as humbling as it has been, I hope that the message is that we are just not prepared to the extent that we absolutely need to be for even moderate pandemic threats, and we are going to face severe pandemic threats in the future.
Thank you very much. Thank you, Tom.
Yes, Dr. Matheny, before I ask Ken Weinstein, I have to comment that we decided 6 years ago that we were not prepared for a pathogen, whether it was a nation state or Mother Nature. We put the recommendations, and as we look at 6 years hence, subsequent, there's still almost an indifference to some of the recommendations we made. And so I want to thank you for the participation and support of the Apollo program. We got to accelerate, as you've pointed out, not only the learning critical to moving forward up on the hill, but accelerate the whole program. So Ken Weinstein.
Okay, thanks, Governor. Dr. Matheny, good to see you, and thanks for being with us. And And yours has been an exceptionally strong presentation and very much appreciate it. Both the way it's been presented, but also all the thought that that goes into your answers. So thank you for that. I guess I want to focus on something you alluded to. You talked about the stand up of ISAC, and that goes to the question of, you know, the mechanisms that are or not in place or are not mature enough to ensure dissemination of threat information, how-tos, best practices, et cetera, among actors within the relevant industry, the biotech pharma industry, so that, you know, just basic sharing of, you know, threat information, et cetera. So, you know, obviously this has been something that arises in all various contexts, and, you know, we saw it up close and personal after 9/11 as it came, you know, as it related to, you know, just trying to integrate all the players across various governments. Here, of course, we're talking about private sector. We're talking about the cyber context, and it's played out obviously over the years in the effort to make sure that different members in the relevant industries are sharing information they learn, so that all members can benefit from that information and trying to build their defenses against the cyber threat. So long wind up to what is the state of play in terms of the mechanisms in place to share that information? Is the ISAC the answer? Is that the sort of mechanism of the future? Is that where you expect that most of that critical sharing is going to happen, or will it happen independent of that?
Thanks, sir. Great question. I would recommend that we look to the cybersecurity community for best practices, just because they have learned through so many painful experiences what works and what doesn't work. And, you know, clearly, if you read the news, you know, even weekly, you will see that we are nowhere near perfection in cybersecurity, but we are farther along in thinking about security and in sharing threat information, detecting threats, finding ways to cooperate to address threats. We're further along in cyber than we are in cyberbio. So I think we should be learning everything that we can from the cyber ISAC organizations and from threat information work that's being done, you know, in places like CISA and DISA and elsewhere, and figure out how to build analogs for the biotech community.
Okay. And is that process underway? Is that sort of part of the interagency process at this point?
No, it is not. And I think this is something I am worried about. I mean, I think it's something that my colleagues are also worried about. I do think we need bio ISACs of the type that you know, that have been proposed for years. I think actually the first time I even thought about it was thanks to some commission discussion of it. So I think we're nowhere near as far along on this as we should be. We do have that you know, in our scope of work to get done here, but we're nowhere near where we need to be.
Okay. Good. All right. Well, look, thanks for the candid answer, and thanks for your presentation today, and good luck with what is a very quite a job ahead of you. And I appreciate you being there to do it, and you're the right man for it. Appreciate it.
Thank you, Ken. Any further questioning from my colleagues on the commission? Dr. Matheny, rarely would I speak for my colleagues, but I think it would be absolutely universal to conclude by saying this has been some of the most sobering and most impressive and most capable testimony we've heard from any single participant in these discussions in 6 years. We appreciate your candor, the depth of your experience as is applied to the questions we've raised with you. We have a lot of empathy for what you're trying to do, because for 6 years, we've been grappling, as you are now grappling with, how do you get well-intentioned people throughout the government who operate in silos to pull together, to build out strategic plans, agree, and then execute consistent with that plan. And right now you've laid out the series of challenges, whether it's, we talk a lot about the nation state, but Mother Nature can mutate pretty quickly. And we're a little wary of what she's doing right now and not sure we're really out of the COVID-19 challenges. And I'm thinking it's very sobering, and I hope you have an opportunity to testify before the Intel community. I probably would, about the severity, and you've talked about it, the would you call it transferability and the lethality of a DNA synthesis, and what our nation states could be doing. But Mother Nature is going to be able to do some of that herself. So I hope you can, you'll be involved with the same kind of candid observations when you probably need to testify in the intelligence community as well. But your open and candid testimony has been very helpful to us. You volunteered to come back. We accept and we look forward to inviting you back again. And we're most grateful for your continued service at such the highest level in support of the safety and security of this country. On behalf of my colleagues, we say thank you very, very much.
Amen.
Gratitude runs from me to you all. Really, there's no more important problem to be working on, and you all are leading the way. Thank you.
Thank you.
Thank you, Doctor.
On this panel too, we're focused on threats, vulnerabilities, and challenges associated with cyber biosecurity, which is the focus of our meeting today. Let me briefly introduce the really extraordinary witnesses we have. First is Dr. Diane DeJulius, who is a senior research fellow at National Defense University, where she works on emerging biological technologies and biodefense. Next, we've got Eleanor Powells, a senior research fellow at the Global Center on Cooperative Security in New York, researching the security and governance implications of converging dual-use technologies such as artificial intelligence and genome editing. And then finally, we'll hear from Catherine Millett, Director of Biosecure, about the work that Biosecure has done and is doing on cybersecurity, cyberbiosecurity risk perceptions in the biotech industry. I mean, we are really out there on the frontier for most of us this morning. So it's extremely helpful that the three of you have given us your time and will now give us your expertise. So Dr. DeJulius, I think I've got all the syllables of your name, and we welcome your testimony at this time.
Thank you so much, and you got the name perfect. That was great. Thank you, and I will say it's a pleasure and it's an honor to be part of your proceedings this morning. So, as was mentioned, I've been working on biosecurity issues at the Department of Defense, and I was involved in a couple of studies related to cyber biosecurity, which I am more increasingly beginning to call digital biosecurity. First was a National Academy study that I think you are probably aware of, entitled Safeguarding the Bioeconomy. And while that report was a large report on promoting and protecting the bioeconomy writ large, we did do some very specific studies into digital biosecurity. And I also, at the request of Georgetown, wrote a paper on sort of parsing the landscape of digital biosecurity. So I want to kind of cover that landscape today, because I think it's really helpful in understanding where the risks are and how we can do risk assessments in this space, is to really look across the landscape and define what we're talking about to understand the best way of going about securing it. So I'm going to talk about two broad areas generally that I think are really important for consideration. And the first area is data, right? Data as a resource, data as a driver of the bioeconomy. And increasingly, I call this biodata because it is biological in nature and it drives biotechnology. Predominantly, it is about genomic data of all living organisms, including human beings, but it's a lot of other data that goes along with genomic data. It's not just genomic data by itself, but it is things like medical health records that go along with patient data, or other phenotypic data that goes along with organism data. So you've got this big set of data here. And the and people are talking about, well, how do we protect this data in a cybersecurity way? Well, the most important way to begin thinking about that is to think about how are we using the data. So first and foremost, we use the data for scientific discovery to understand how genes function in disease, how they function in health, how organisms function, right? Learning about basic science and technology there. And we use bioinformatics broadly to do those studies, right? And then the next step, we take it to the next level and we do something called biodesign. So this is where you're actually using that genomic data and what we learn from it to engineer living organisms, to engineer biology to do stuff we want it to do. So by and large, a lot of this is about creating high value chemicals, compounds, materials, et cetera, and building manufacturing platforms that make things by using biology instead of using petrochemicals, right? So this is a big ground shift in how we may produce things here in the United States. And it's driving a big component of our bioeconomy. So as we think about using data for biodesign, a lot of the importance of that data is starting to go into intellectual property, right? It's starting to go into data that companies have and that companies are building so that they can build these platforms for biomanufacturing and build cool products that they want to sell in the marketplace, driving a big piece of our bioeconomy. And then the third way is what you all are familiar with, and I know you all talk about quite a bit, and I'm gonna call that broadly biosurveillance. Okay, so this is not just biosurveillance for disease outbreaks, it's disease outbreaks of humans, animals, livestock, wild animals, plants, right? But it's also all this other stuff that's growing now as well. Things like being able to track invasive species by their genomic signatures and their biodata, being able to track a gene drive that might be released into the environment, right? We just had engineered mosquitoes released in Florida quite recently. So we need to be able to track those. We're going to use data to do it. So as we look across these sort of three categories of stuff, learning about biology, marketing with biology and biotechnology, and using data in the public health space and in the environmental health space, you can start to think about, well, which kinds of data do we need to build some high walls around and protect versus which kinds of data is actually going to be better to share, and the benefits of sharing that outweigh any risks that might come associated with it. So in my mind, two big areas, of course, where we need to look really hard is on pathogen data, how people may be using pathogen data because it can be used for harm. And then secondly, potentially human data and all of the associated medical records data that goes along with that, and how are we protecting that? So I've been sort of supported in my thinking on the human data. Just last week, the Biden administration came out with an executive order tasking the federal government to look at human data and medical records to do these kinds of risk assessments and figure out what's the best way we should be thinking about protecting that data if it indeed is at risk. So we'll see what comes out of that in the coming weeks. So, okay, so I said biodata was one big chunk. The other big chunk where we need to look at the landscape is what I'm calling sort of physical cybersecurity that interacts with biotechnology, right? So one reason we have a thriving bioeconomy is because increasingly we have an intersection of information technology with biotechnology. And every point at which those two intersect is a potential point of cyber vulnerability. And we need to look carefully at those, again, to say what kinds of risk is there and how might we go about protecting against that risk. We have to be careful too, because it is exactly this kind of intersection which is driving the bioeconomy. It's driving innovation, right? We're using all these informatics tools to do things with biology that we couldn't do before. And again, it's what's driving biotech and the bioeconomy. I'm happy to give examples of that, by the way, if there's time during the discussion. So in thinking about that, it is, okay, if you're a biosecurity professional like me and you talk to cybersecurity professionals, they all say the same thing. They say, well, that's just cybersecurity. That's just good cyber hygiene. You have buildings that house biological research and you need to control them and for access and control their temperature. And if you're working in a biological containment lab, you want to make sure that your air flows and your water flows and there aren't any external contaminations of microbes out into the environment. All those things that are increasingly controlled by automated technologies, again, represent a vulnerability for hacking, tampering, etc. But then there's a whole, okay, I agree that there's some good cyber hygiene that could be done. And in the National Academy study, we talked about some of the low-hanging fruit there that companies and laboratories and those doing biotech could easily adopt to help mitigate some of that risk. But I also believe that some of the cyber technology that is connected to biotech is uniquely biological. And I'll see if I can explain that even a little better. If you have technology that is actively performing biotechnology capabilities, tampering or negative outcomes from cyber intrusions of those specific kinds of things represent specific kinds of risk, right? So we don't want vaccine platforms to be tampered with if we have fermenters that are, making biological biochemicals, for example, from yeast or from E. coli. We don't want those to be tampered with in such a way that they do damaging things caused by biology, right? So it's not just strict cybersecurity. Can somebody get in the building or not? Or can somebody tamper with a thermostat? But it could be much more impactful things that cause negative bio events like escapes into the environment and so forth. So those are kind of two really big broad areas. And I know I've skimmed over them really quickly, but I think in my closing remarks, I would say that there are some important questions that we could be asking. And I'm so glad all of these smart people here are asking these questions. So number one, what kinds of bio data need protection and from whom? And to answer that question in the best way, we need to think about who the end user is and what their intents are for using the data. And then secondly, I think we need to really start thinking of strategically about what data has strategic value in the bioeconomy, right? I talked about these companies and having their intellectual property that's subject to theft. And that could be aggregated or annotated data that's been managed very carefully that becomes much more valuable than just a database sitting out somewhere. And finally, how will we use biotechnology in the future? I think it's going to be really important for the United States to figure out what our bioeconomy strategy is, because where we want biotech to take us will dictate how we get there and what things we need to protect along the way to get to where we want to be with our bioeconomy. So again, I know that was really fast, but I will end my comments there, and I look forward to the discussion. Thanks for your attention.
Thanks, Doctor. That was a great introduction, and you're a good teacher. So I appreciate it. Next, we'll go to Eleanor Powells. It's all yours.
Thank you so much. Esteemed members of the panel, thank you for the opportunity to speak with you about existing and future challenges in cyber biosecurity. I truly believe that the mandate of this commission is of critical importance, as one of the most significant legacies of the global crisis we face will be the way that the pandemic dovetails with another major global disruption, the convergence and democratization of AI and biosciences. And several of my research projects and my research interests in particular focus on applying foresight, threat forecasting methods to the convergence of AI, cyber, and biosciences. And so today I would like to share with you 3 strategic insights and policy priorities. So first, the integration of AI within biosciences lead to game-changing opportunities, but also profound and unique security concerns that fall outside our legacy governance policies. And in particular, we face a new typology of AI-led cyber threats designed to manipulate and corrupt the integrity of data sets and algorithmic models, crucial to the global knowledge production cycle in biomedicine, in biotechnology, and also in biosecurity. Second, such emerging threats may not only produce collective harms due to loss of data integrity and possible lethal outcomes for populations, but may also drastically undermine scientific and public trust, both scientific and public trust in the bioeconomy's critical information infrastructure. And so the COVID-19 pandemic has crystallized just how trust in biosciences is a powerful element of our social contract. Third, the convergence of AI and biosciences is an epistemic, industrial, and security revolution that already impacts most critical sectors of our societies, from health systems, food production, biomanufacturing, to non-proliferation. And this convergence is therefore critical to preserving a nation's security and sovereignty, but it's also taking place in a context of rising geopolitical tensions where foreign actors could use adversarial data manipulation to gain leadership by undermining capacity and trust in the US bioeconomy. So let me start with briefly eliciting the most powerful aspects of this revolution at the confluence of AI and biosciences. So in the last 2 decades, biosciences have moved from analog to digital, converging with AI as an innovation catalyst. The new collaborations between AI and bioengineers have led to the field of functional genomics, a more precise understanding and optimization of functional processes in genome biology. So deep learning algorithms can improve analysis of the combinatorial relationship between genotype and phenotype in genomics and omics datasets related to humans and pathogens. Such algorithms can also help test genetic functions in silico, providing scientists with needed analytical tools to engineer biological functions with new level of specification. So the convergence of deep learning and biotechnology could therefore play a significant role in the design of bioagents, impacting both genome editing and gain of function research. The new frontier of functional genomics is increasingly developing in silico, so producing important knowledge insights that build on synthetic data sets, as well as algorithmic computing. And these sensitive digital assets provide powerful opportunities for our societies that go from improving trust in precision medicine and medical countermeasures to automating reproducibility and efficiency in complex biotech supply chains and isolating potential harmful genetic functions in biosecurity screening. Yet, at each stage of the information lifecycle, the digital infrastructure that underpins biosciences is a target for AI-led cyber attacks, in particular, adversarial data manipulation that could sabotage and weaponize biomedical research, clinical trials, biotech facilities, and supply chains. And here are 3 types of potential threats. First, manipulating the integrity of biomedical research and population data sets. So research in AI security has demonstrated how certain types of AI-based malware can be trained to drastically undermine the predictive ability of a wide set of medical analysis systems that are based on deep learning. In 2019, researchers at Ben-Gurion University designed an AI-based malware trained to manipulate the integrity of cancer data in hospital CT scans, producing false lung tumors that conform to a patient's unique anatomy, leading to a misdiagnosis rate in excess of 90%. Engineers at Harvard University tested adversarial attacks against algorithms used to diagnose skin cancer, showing that such attacks only required modifying a few pixels in the original biopsy picture to corrupt the diagnosis. So as medical intelligence about the treatment of cancer, brain lesions, and infections could be manipulated, adversarial attacks on deep learning pose a substantial risk to our most critical medical and clinical infrastructure. Yet the attack surface extends beyond medical diagnosis and clinical trials, with malware that could target the integrity of genomics and other omics datasets related to humans and pathogens. So researchers at Sandia National Laboratory have demonstrated how autonomous malware could be used to manipulate subsets of data within large curation of human genomes. The malware could be used to target the functioning of genetic analysis software to alter actual fragments of DNA sequences within individuals' genomes. Such malicious alteration could result in misdiagnosis with an impact on clinical decisions. But this type of data poisoning could also affect in silico predictive models in functional genomics, including how we diagnose and treat complex genetic diseases, how we analyze the pathogenicity of viral and microbial threats, and how we develop adequate medical countermeasures for subgroup of patients. So what is at stake? It's really the global knowledge production cycle in biomedicine. Second type of threat, the sabotage of biomanufacturing. So new capacities in automation, including within cloud labs and commercial DNA sequencing and synthesis, provides increasing potential to hack and compromise automated protocols that program and standardize the instruction of a biotech experiment. An AI-based malware could target vulnerabilities in automated protocols to corrupt networks of sensors and duly impact safety and quality control processes of a biotech supply chain. So resulting harms extend from making pharmaceutical products that do not match specification standards, leading to waste and shortage, to spoiling vital stocks of vaccines, antibiotics, cell or immune therapies for cancer treatment. The cyber criminals and state actors have already mounted targeted cyber operations against firms researching COVID-19 vaccines, and the underlying goal could be to access and manipulate shared information about how the vaccine is shipped, stored, kept cold, and delivered. So compromising the automated functioning of biotech laboratories could escalate into biosafety concerns. And importantly, no adequate guidance exists to prevent the adversarial use of biological data, algorithmic models, and automated protocols with the aim to produce a biosafety or biosecurity consequence, in particular when such offensive techniques exploit vulnerabilities in the cyber biosecurity infrastructure. The last type of risks is about corrupting biosecurity screening. So by improving our knowledge of DNA functions, AI computing is becoming an integral part of biosecurity screening mechanisms, preventing illicit gene synthesis and experiments in gain of function research. So for instance, US biosecurity programs and gene synthesis companies are developing computational threat models that can be applied to characterize the function of novel combinations of DNA sequences. And similar algorithms play an increasing role in microbial forensics, using their capacity for anomaly detection to identify the specific signatures left in modified organisms. So adversarial attacks could be designed to corrupt the predictive ability of screening algorithms to identify threats based on functional analysis of DNA sequences. By obfuscating functional data from sequence of pathogen and toxin DNA, AI-based malware could manipulate the integrity of the data sets shared by stakeholders to train a screening algorithm. And such data manipulation could drastically undermine the confidence level of screening algorithms when they aim to ascribe threat potential to known and unknown genes, including genes responsible for the pathogenesis of viral threats, bacterial threats, and toxins. So in closing, it is important to stress that the AI and cyber infrastructure supporting biosciences is both a global public good, but also a potential target for covert data manipulation. And in light of these challenges, recommendations about next steps and priorities should be: first, learning from and across the AI, genomics, and cybersecurity communities. So across these sectors, there is a need to explore and implement red teaming, formal data authentication and verification protocols, and responsible disclosure of AI cyber vulnerabilities. The goal is to maintain the integrity of data in motion and data at rest, and therefore preserving integrity over the life cycle of data sets, from collection, curation, processing, analysis, and long-term storage. And second, there is a need to apply modeling and threat forecasting methods to assess targets and vulnerabilities across the AI, cyber, and biosecurity sectors. And this form of sandboxing or operational foresight could also help detect new vulnerabilities emerging from human-machine interaction in modern biotech. And finally, as for critical services, a foresight and mitigation effort should consider as a priority to preserve trust in the US bioeconomy and see it for its security and sovereignty implications, given that other powerful nations could fill the gap by acquiring crucial population data sets, AI and computing technologies, and by influencing global discussions on AI and cybersecurity standards. So I will end with these thoughts. Thanks for your attention.
Thank you very much. It was excellent testimony. You're carrying us along into the new world. And last on this panel, Catherine Millett. Catherine, maybe you're going to do this anyway, but it would help if you started out telling us about Biosecure and what it is.
Yes, certainly. Hello. So as you know, my name is Catherine Millett, and I'm the director and co-founder of Biosecure Limited. So we were the first company founded explicitly to safeguard the bioeconomy. And since 2014, we have been providing advice and support services to academia, industry, and governments in minimizing biorisks and maximizing biorisk management. So we've also been raising awareness and contributing to the field, to the evolution of the field of biosecurity since 2017. But first, thank you to everyone on the Bipartisan Commission for Biodefense for having me today. It is a great honor to be here, and I am indeed humbled to be addressing you on this vital issue of the threats, vulnerabilities, and challenges that have emerged as the biological and cyber science and technologies converge. So we know that there are clear dangers from unsecured biological data, products, services, and equipment to the bioeconomy, public health, national security, environment, and society. And previous panels here today and in your first cyber biosecurity discussion have done a formidable job in providing clear viewpoints and identifying specific risks and areas of vulnerability. And more recently, academia in particular has been broadening and moving these conversations forward. My comments to you today will focus on what we don't know and how we can get better at finding it out. But I also want to start by reiterating the importance of being clear on the following: of what we are protecting, what we are protecting against, who must be involved, and the need for unambiguous messaging and clear guidance. So this nascent realm of cyber biosecurity presents a number of very unique challenges. The very nature of biotechnology and cyber domains make it hard to know the right things, particularly as they are highly innovative, volatile, and diverse. This makes cyber biosecurity a moving target. The rate of change and diversity of relevant new enterprises, products, information, services is overwhelming, especially from the perspective of those charged with developing policy to govern it. And consequently, cyber biosecurity requires managing an almost unprecedentedly broad range of risks that range from tampering with critical manufacturing cyber physical systems through to the unwitting manipulation of dangerous pathogens and beyond. And today, we do not have we've not been able to sufficiently be systematic in our approaches to biological risk and cyber bio concerns. They have most often been viewed as an IT issue. And at this juncture, really, we need to start thinking more holistically and engage in a dedicated and comprehensive mapping initiative to fill in those gaps and ensure a robust understanding of where vulnerabilities arise. Obviously, this will necessitate a bona fide multi-stakeholder engagement involving manufacturers and suppliers through end users, as well as all the relevant government departments, agencies, bioindustry, biosafety associations, and more, and across all sectors of the bioeconomy. And once all these relevant actors have been identified, it then becomes necessary to ensure that these different communities become socialized and overcome differences in terminology and priorities and approach and begin to develop a shared culture. We've learned from other biosecurity efforts that this does take time and support and can most readily be achieved through joint exercising. We don't know enough about what we're trying to protect, which types of biological facilities using what technology are potentially susceptible to malicious intrusion or tampering or theft. Should we be more concerned about government laboratories, private or commercial labs, biofoundries, factories, university laboratories, or even community labs? Like, how do we compare risks to these physical facilities against those to non-physical databases or machine learning tools or other kind of software? And in this, our baseline data is very, very weak. So even in comparatively simple cases, such as details of laboratories capable of working with dangerous pathogens, there are important gaps in our knowledge. So a recent study that was led by George Mason University and King's College London noted that there are almost 60 BSL-4 labs worldwide in over 23 countries, half of which have been established in the last decade. But what about BSL-2 or BSL-3 labs? These are also used to work with dangerous pathogens, including many that have been weaponized in the past, excuse me, and are currently subject to export controls precisely because of that potential for malign misuse. And these key gaps in our knowledge go much further. There is not enough to restrict our focus to such traditional dual-use facilities. We do need to think more broadly about the potential for malign misuse and consider a much more diverse range of enterprises and products, etc., that do make up the modern bioeconomy. And we know that resources and equipment vary considerably across companies and facilities. And the specific makeup of these will determine how susceptible they are to cyber intrusions and attacks and how capable they are of preventing them. We also still do not know enough about our vulnerabilities. We do not have a comprehensive understanding of what kind of cyber biosecurity measures and practices are already implemented, if at all, at relevant biological facilities and other entities. And with no overarching cyber biosecurity standards in place, cyber bio practices and measures will vary across facilities and entities depending on their size, their focus, and their turnover. So there are currently no data sets that allow us to assess how facilities and entities are practicing any adequate cyber biosecurity, and whether their policies and practices are simply cyber security based, IT security based, or have been more specialized. And this is all compounded by an overall lack of awareness of cyber biosecurity risks and the need for tailored responses. When we canvassed a small sample of private companies in 2018, we discovered that while over 2/3 of respondents deemed cyber threats and intrusions to be an elevated or severe risk, their perspectives were attuned to the commercial consequences as opposed to a broader recognition of any potential public harm. There were clear variances within the levels of awareness and risk perception, and for most adequate cyber biosecurity measures had broadly yet to be identified and implemented to address any risks. An ongoing study that we're currently undertaking focuses more downstream on laboratory practitioners and biosafety, biosecurity personnel, and this is across the globe. And this study is in its early stages and the results are so far tentative, but at present, less than 1/3 of the respondents are aware of the field of cyber biosecurity, although over 3/4 of them feel that it is an important aspect of their day-to-day work. Few participants could identify any training or awareness raising offered within their workplace. And when asked to identify who should have responsibility and oversight for cyber biosecurity issues, responses were unsure and split generally between biosecurity, biosafety officers and the IT department. Which brings me to our recommended next steps. So firstly, we must undertake comprehensive landscape mapping. We do need to better understand what and where all the risks are. And as mentioned, it will require involvement by all stakeholders across the bioeconomy. Excuse me. Secondly, we need to undertake some robust and sustained awareness raising and training. So despite the increasing attention that has been paid to cyber biosecurity over the last few years in policy and discrete academic circles, it's still not an active issue for many broader academic or private sector facilities. And the biotechnology industry seems to continue to be in what some have called a state of naive trust. So discussion of this issue should be integrated into existing efforts on both cybersecurity and biosecurity. And it may be necessary to bring specific opportunities to bring together these disparate communities, bring them out of their silos and help them socialize and begin this process of developing a shared culture and sharing information and ideas. Thirdly, we'll need to develop novel security tools and approaches and clear standards. What we have inherited from the past will likely be insufficient to tackle any future threats. We need to get better at experimenting with governance options. So as Dr. Vice Evans of Harvard University argued, there is no capability so far exists for systematic learning about the effectiveness and limitations of current biosecurity governance. The understanding and approaching this governance as an experimental space perhaps will enable us to make more than sporadic movement toward reactive approaches as we move forward and think about what we would like to do in the future and where biotechnology will be going in the future and what risks these may entail. And lastly, I am finishing, we need an increasingly global outlook. Now, the US has been leading developments in protecting the bioeconomy and in the field of cyberbiosecurity. The US also leads the world in biotechnology, but other countries are heavily investing in this area. So and there's also a rise in laboratories and databases worldwide, and global transfer of technology, services, products and materials. Under these circumstances, no country can tackle the risks associated with cyber biosecurity in a vacuum. We are well aware of the possibility of what happens in a laboratory or facility in one part of the world could cause serious real-world harm across the globe, commercially, economically, to public health, societally, and so on. Very few other governments are really taking any notice of cyber biosecurity. So in this way, we think that the US should show leadership by beginning dialogues and workshops with its close allies to explore the threats and vulnerabilities addressed through cyber biosecurity. More broadly, as there have been no separate discussion of cyber bio at key international processes such as the Biological Weapons Convention or in the joint evaluation exercises carried out by the World Health Organization, the US also has an opportunity to show leadership here in ensuring that this issue makes its way onto future agendas. Once again, thank you for the opportunity to address this esteemed commission, and I look forward to any questions that you may have.
Thanks very much. Talk about sober, which is a word we've been using a lot this morning in response to the testimony. Your testimony is also sobering because you're telling us that there's a lot that we don't know, including what the vulnerabilities are and what we should be protecting. I can't resist on the last points you made, and I'll maybe ask others on the panel this. Isn't the possibility that the COVID-19 pandemic started out as a result of an accidental leak, to put it that way, or an accidental release of the virus from the laboratory in Wuhan? Doesn't that really give us an example of exactly one form of the threat that we're facing, that is the cyber biosecurity threat?
Yes, absolutely. I mean, the possibility that the leak has been caused by, I think, some theories come across, it's like there has been bad waste management, or there's been some issue with flows, so there's this accidental exposure, and then that's been
right.
passed on. So, it seems to be that there may well be a more likely physical part to that if, as you say, it should be known as an accidental an accidental release case. But yes, the information there could also be, is also extremely important. And when you have this kind of very risky information that's not best protected, you just don't know where it could go across the world. We're so interconnected.
Right.
It's not, obviously, we always say disease knows no borders, but neither does information.
Yeah. Tell us a little bit more about that study that your firm did of the biotechnology sector. So you made the statement, which I'm sure we'd all agree with, about the sort of lack of awareness of the vulnerabilities generally and the threats, the cyberbio threats. But I'm interested because obviously these are people in biotechnology who are in this field. And so give us a little more texture about what you found about their awareness of or sensitivity to the threats.
Of course, yes. So the survey was actually originally completed in 2007, the end of 2017, in advance of a G8, or perhaps it was G7 global partnership meeting. The global partnership against the spread of weapons and materials of mass destruction was carried out at that time under the Italian presidency. The survey had quite a small pool of participants, and they were drawn from the biosector as well as the cybersecurity sector. And from the biotechnology sector, we had basically founders of small to medium emerging biotech companies in the US and the UK, and senior management of large biotech companies, industry representatives, venture capitalists and security advisors. And within the cybersecurity area, the people that we surveyed were essentially industry specialists, academics, government experts, and also specialists within international organizations. So what we aimed to do was we looked at the participants' threat and risk perceptions of this cyberbio nexus. So where any risks and threats were considered to lie or could be foreseen to arise. And whether or not anyone had started to consider or implement any specialist risk mitigation strategies, and if so, what did they look like? And what we found was that there was quite a lot of variance in these risk perceptions. So there was a general recognition that potential unauthorized access, theft and information tampering was a high risk area, although the risk was considered less so in regards to the ability to hijack cyber physical systems, which I know has been mentioned to you in the previous panel in 2019. And I recall one respondent didn't see any risk for any of these at all. But for the most part, the participants identified any risks and threats as directed towards their companies and their commercial interests, with very, very little recognition for the potential for broader societal harm. State proxies were seen as those posing the greatest threat. So this lone actor hacker wasn't seen as being of any real particular concern or danger. And on the risk mitigation steps that participants had taken, there was a notable lack of any real action taken beyond efforts to increase cybersecurity protection, so IT protection. About 3/4 of participants reported that their company had taken action to address and secure against cybersecurity issues, and that they would be regularly reviewed. Some of those sort of included where their company only worked with other entities that had proven strong security cultures, such as Google and Microsoft, for example. But then moving beyond IT solutions, it was noted quite commonly that there was a lack of information on the type and severity of the risks where the cyber and biofields intersect. And a number of those participants expressed difficulty in knowing where to even start or where to look for expertise in helping them figure out the risks and then see what mitigation strategies and approaches they could take. And within those responses also, it was pointed out that each company is unique with its own level of resources, which makes it more difficult to devise appropriate protocols. And so to this end, again, we had quite a few responses that brought up the need to undertake this comprehensive gap analysis for each country or company or facility across the biotech industry.
Okay.
And yeah, sorry, just lastly, about over 90% of those participants did have a strongly held view that there was just not enough time and resources available that was being dedicated to cybersecurity at that time, identifying and responding. So they seemed very keen to learn more. except for one respondent who was entirely skeptical of the entire survey and the emerging field of cybersecurity, biosecurity itself, and remarked that it smacked of an attempt by academics to build a new area of funding for themselves rather than posing a real threat or risk.
Only one. That's good.
What?
Yeah. Okay, thanks. I want to try, unfortunately, shorten, ask you for just both the other two witnesses to respond. Similarly, Dr. Delius, I wanted to ask you how we've just been through this still in extraordinary COVID-19 pandemic, which is related to the work that you do. And I wanted to ask you how it's influenced your thoughts on the cyberbio threat and also the potential responses to that threat, since in some ways the COVID-19 story is a remarkable story of the response of society, public and private. And then Ms. Pauls, I wanted to ask you briefly just to talk about anything that you learned from the COVID-19 pandemic that perhaps surprised you, that relates to what you focused on, which is the vulnerabilities stemming from the convergence of artificial intelligence and biotechnology. So it's unfair to ask big questions and ask for short answers, but in deference to my colleagues, I do that now.
Yeah, I'll try and be brief. That is a big question. And I will say that at the WMD Center, we're actually having our annual symposium this week. And I did a study on what have our adversaries learned from our response to COVID-19. So I'll be talking about that tomorrow if people are interested. But as directly relating to your question about cyber biosecurity or digital biosecurity, yeah, I think those are really, we've learned some important lessons about this. So on the one hand, we've seen the tremendous value that data has. We were able to, Moderna, which I think started as a company of about 3 people a couple of years ago, and now has produced the most valuable vaccine potentially in the world, started with a few hours of digital modeling, doing biodesign in silico. Once they had the sequence of SARS-CoV-2, they were able to come up with vaccine candidates that they worked on for a very short period of time, and were able to advance really rapidly. So we have to think about the power of the digitization of biology and what it was able to do in the pandemic. At the same time, we've seen, which I think my colleague Catherine has discussed in her talk, that we've seen attacks on vaccine production facilities. We've seen hacking into the information around the pandemic. And what I find very interesting is that our adversaries, our competitors, if you will, in both biotech and the bioeconomy, were in the same race in producing many of these high value items in the bioeconomy. And so from that perspective, we know that this digital information is really valuable, right, in a global sense. And so again, having these conversations about what are the best ways to generate security in this space are going to be really important. I wanted to say one more thing, just following on Catherine's comments that I thought were excellent. With a colleague of mine, Sarah Carter, we did a very small study. It wasn't just about cybersecurity. It was about many things in the synthetic biology industry. One message that we heard clearly, and many of the responses that Catherine got to her survey were things that we saw also in our study. In other words, very wide discrepancies in the use of cyber biosecurity across the board, from small to large companies, very different ideas of what it is and very different experiences. But one thing we heard from them at the meeting we had in Washington, DC, was they want a forum to talk about these issues. And they want a forum where they can talk about sensitive issues of cyber intrusions that don't damage potentially their company's reputation, but where they can safely talk with other companies and say, have you encountered these problems and what have you done about it? And what are best practices that we can and all should be using? So, so I just wanted to chime in and foot stomp a little bit what Dr. Millett had already said.
Okay, that's a helpful stump. Ms. Powles?
Many thanks for your excellent question. Something I would like to stress is that when we talk about the digitization of biosciences, the tools that make it possible to actually analyze so much data and optimize data sets and get insights from them, those tools come from artificial intelligence. So, AI is literally the innovation catalyst in this revolution we're all talking about. And you saw that during the pandemic, since it's an AI-based computing platform that was used for synthesis and functional characterization of the virus that we were all concerned about. And so such platform, help not only do functional analysis, but also think about next steps in terms of medical countermeasures. AI will also be a revolution in terms of how we do situational awareness, disease surveillance, preventing future zoonotic spillovers, and working on more efficient diagnostic systems and countermeasures in real time. So you really have here, almost the future of the biomedical, biotech, and biosecurity enterprise relies on the use of artificial intelligence. What I wanted to stress in my remarks is that this integration of AI creates new threats for which we are not prepared at all. So, when we discuss the biosafety concerns around the origin of this pandemic, we are talking about risk that we can know, that we could know, that we kind of know the methods and the type of assessment we should do to be able to prepare. In the case of the integration of AI with biosciences, what I was explaining in my remarks is that literally you can use algorithms to manipulate data sets in a way that were not possible with previous cyber threats before, which means that you could literally force an institution to resequence all of the genomes of individuals that they have in their back. You create this form of distrust, scientific empathy to the type of data that you have. So it's almost, creating a threat that originates much before a physical consequence or a biosecurity or biosafety consequence. It's at the level of our knowledge. What do we understand and what do we trust in terms of data that we are using? So that's something I wanted to stress. Something that surprised me with the pandemic, it's really, the demonstrated power of that convergence in terms of accelerating response to a global pandemic.
Right.
It is to sovereignty and national security. The problem is that if we use AI for disease surveillance, for medical countermeasures, for better vaccines, we need to be able to trust those systems. And so there is not yet a theoretical understanding of the vulnerabilities and the failure in terms of predictive analysis that could be inherent to those systems. That's a knowledge that should be developed by AI engineers, but they don't work on these issues related to bioscience necessarily. They think of AI for, working in different financial or advertisement type of sectors. So how do we create that theoretical knowledge that can be applied to the biosciences so that we don't run into this problem of trust decay that we could literally be facing? It's a type of attacks that would be very difficult to detect and extremely difficult to attribute. So it's the next level of weapons of malware that a nation could use for being able to paralyze another country without, having with a total covert intent and covering its tracks, basically. So that's really what I wanted to.
Yeah, thank you. We are really forewarned by your testimony. Governor Ridge?
Thank you, Senator, and expression of deep gratitude to this panel. We've talked about sobering information. This is chilling and basically testimony is really elevated, at least for my purposes, the sense of the huge vulnerability that we have that is really both unknown and not terribly well understood by people who could make decisions within government in order to reduce our vulnerability. So I was caught by Dr. Julius, your comment about how the biotechnology world would like to have a forum where they could share practices and share information. And our earlier speaker, Dr. Matheny, and I, we were all talking about some kind of information sharing advisory council, so that in a confidential way, potentially encrypted way, there could be a communication between the government and the private sector and entities within the private sector themselves. I can only presume that you would embrace such a, not such a concept, but such a formal organization for that purpose.
Yes, sir. I would agree with you 100%. And I should have said during my remarks as well, in the National Academy study that I participated in, we talked about ISACs that you mentioned. And the interesting thing there is that there are different ISACs for different sectors, right? And so when it comes to the bioeconomy, because it covers so many different sectors, it's not just health. It's also agriculture, it can be energy, it can be commodities, it can be all these different components. So the idea being, how do we set up an ISAC that would address the unique cybersecurity considerations of the bioeconomy? So yes, sir, I agree with you 100%.
I wanted to ask you, Dr. Julius as well, and Ms. Powles, both of you referred to AI manipulating data. Eleanor particularly talked about you manipulate the data, you create mistrust, mistrust creates instability, instability creates all kinds of different challenges for governance. Start with governance. But how do we reach, is it possible to reach a consensus between the public and the private sector as to what data must be shared that's inviolate, that regardless of its source, it must be protected rather? And can there be a potential consensus within the industry, within the bio industry, as to what data could be shared? Because the sharing of that data gives us an opportunity to, one, anticipate and build the antiseptics or the antidotes to the potential pathogen. Help me with that. How do we identify, universalize the data we need to protect, inviolate, don't touch it, and the data we can share? Is there a possibility to reach a consensus? Interested in your responses.
Yes, that's a hard question. And
You help me pose it though. With your
I alluded to that in my remarks. I don't have the full solution, but I think
we got to take a first step.
Yes, absolutely. So how I will answer you is yes, I think we can get to that place of determining what data is best shared because it's in the interest of public health. And so, for example, I can say that much of the data that's utilized by companies, right, that are doing biological engineering, that are doing creating products in the bioeconomy, they will tell you that raw data, unaggregated raw data, like things that are in GeneBank and some of these other databases, that as a company, that doesn't offer too much value to them. Where the value really increases for a corporation, for an industry, is when they begin to engineer that data, when they begin to apply sort of their own trade secret technologies, like what's the best way to, ferment this, yeast to get it to produce vanilla or whatever is the commodity chemical they want to make. That's really getting into where their intellectual property is into all those aggregated tool sets. They've applied a lot of different tools to the data, but they'll tell you that the raw data, everyone could use that and they're using it just like everyone else. And it's basically what they're doing with the data much further along the road where they get their intellectual property value and their product value. So that's from the company's side. So personally, I feel in the public health side that we really need to share information for biosurveillance. I think that's critical. And if COVID-19 has taught us anything, we need to do that faster and better and more comprehensively all around the world. So I, in the interest of time, I'll stop there and let Eleanor also respond.
Thank you so much. And this is indeed a complex question. I would almost reverse, the perspective on this question, thinking about, so if you approach this thinking that artificial intelligence is an innovation catalyst, you will need in the future, you will need infrastructure where where interoperability and data sharing is a given. So you will need to be able to do that form of data sharing. If you want to use an AI platform, not every hospital or every genomics analysis center will have the best tools. They will need to use global public tools, if you see what I mean. Or so this infrastructure is so heavy and so high tech and so innovative that there will be a need to be able to use it, to share it, literally. And so it's, I think, it's difficult to think about how to stop data flows in an enterprise that's so key to public health, disease surveillance, pathogenic surveillance. So I would almost not necessarily think about what should we enclose and not share, but how can we share safely? And so there are a host of techniques that you could use to actually share information in a way that you preserve data integrity. So we absolutely need to invest in research and the technical consortium we've been mentioning that would be cross sectors, AI, genomic security, cybersecurity. That type of consortium should be thinking about the technical solution we can design to be able to protect the integrity of data sets at rest, in motion, at different steps of the life cycle of this enterprise. Because for all kinds of reasons, you will still need to be able to share, and even more, the most sensitive data sets. So you can use cryptographic checksums for data authentication. You can use multi-secure party computation. That's a skill set that we need to develop as a nation that's leading, this convergence. There is no way around it or backward, basically.
Thank you very much.
Thanks, Tom. Senator Dash.
Thank you, Joe. Let me thank our panelists for their very thoughtful presentations and the answers to our questions to date. In the interest of time, I think I'm going to limit myself to one question for each of the panelists to answer, and that is, this is certainly a new, very complex, multifaceted area for public policy. If you were invited to provide the guiding principles in the creation of sound public policy dealing with these critical issues today for both the administration and the Congress, what would be the one or two most important guiding principles that they ought to be mindful of and cognizant of and sensitive to as we draft public policy going forward? Dr. Gillis, why don't we start with you, and then we'll go to Eleanor and then Catherine?
Okay, another really tough question, but I think that for me, I would say that we need to take a hard look at those two areas of that I have concern about, and one is around pathogen data and the other is around human data. As I mentioned, it looks like the administration is already interested in making some moves towards thinking about how we might protect human genomic data and medical records. I think in looking at risk assessments, those are two areas that seem like a hot button to me. And on the other side of that, I think that basic research and innovation, sort of data and all of the things that are driving basic research and innovation should remain open. So that if we look at where we would want to apply some good public policy, it would be definitely in the interest of where there is the highest risk, as opposed to potentially limiting benefits from those others. I will say, because I'm with DoD now, as opposed to HHS where I used to work, I will say there are some unique considerations that we have to take in DoD as well, in terms of protecting warfighter medical information and genomic data, because warfighters could be targeted, particularly in biological ways. So that's something I'm concerned about. I am also concerned about just sort of in the synthetic biology industry in general, there's a lot that we don't think about. So for example, if I'll just give you one example on the DoD side. if USAMRIID is ordering biotech, synthetic DNA from a biotech company, it will be very easy to know what USAMRIID is working on by looking at those orders, right? And so, synthetic biology companies have said, if somebody hacks into our ordering system, they'll get to see everything that DoD is working on just by looking at those orders for particular biotech components and parts. And so I think we've scratched the surface. I think pathogen and human data is something we have to be really careful about. And I think DoD probably has some unique scenarios that require a harder look. I hope that's helpful.
Thank you so much for your question. I would approach this question from the perspective of methods. So I think what I would recommend as research and policy priorities is really to create this space, either the space or the methods to be able to do cross-sector and cross-fields exchange of information towards those new solutions I was talking about. So we still have the biosecurity field, which is siloed from the AI security and cybersecurity fields. Same silos apply in the automation of biotechnology, right? So in the private sector domain, for example. So you have, for example, exceptional programs at DARPA that are working on robustness of future AI systems. At the same time, you have extremely interesting programs at YARPA that are working on functional genomics. Those programs, those people need to talk to each other. And that's, to some extent, a certain level of high-level research, but they need also to be sharing the knowledge they would build together across sectors. They need to share that with a safe layer of other stakeholders that we need to protect and to introduce to these new challenges. So cross-sector, cross-field, and as I'm talking about new methods, I think we need to do better threat forecasting. So we need to be able to model those type of attacks, type of vulnerabilities, and that's something that you can do with modeling, that you can do with specific research methods, and that would be exceptional to do that across AI, cyber, and genomic security.
Thank you very much. Catherine?
Yes, so my comments just tie very nicely into Eleanor's last point, that I think one of the guiding principles really is that as we're looking forward, we need to be very nimble and have a future leading approach. So that means that we need to be sustained, and we need to really kind of watch what is happening in the world, how the future labs are developing, what new technologies and things are actually emerging in our dynamic space. So we need to have an approach that was going to allow this constant forecasting and future landscaping. And then one of the things I would just say that would be important would be linking up with existing biosecurity standards. I'm not so hot on my cybersecurity standards, but not to reinvent the wheel, but if we are able to kind of link up and update some of those existing standards, like the WHO laboratory biosafety, BioRisk standards, their biosafety manual, biosecurity manual, maybe link into the ISO of 2019, the biorisk management for labs, and bring all of those into more relevancy and bring the cyber biosecurity concerns into that I think would be a really useful thing to do moving forward.
Well, thank you each for your thoughtful answers. Joe?
Thanks, Tom. That was a great question, and I agree with you. Very helpful and thoughtful answers. Secretary Shalala.
Thank you very much. I think we've covered a lot of issues. I'd like to go back to Tom's question and ask each of these experts, since there's a wide range and level of sophistication and between the various sectors that we want to put security systems in, where would you start? I mean, if you had 15 minutes with the President of the United States, where would you tell him to focus? It's one thing to focus on who has the data, but what sector where we would get the biggest bang out of the buck would be the most important, where we would learn enough so that we could put systems in place across the board?
Thanks so much for your question. I think I'd go back also to one of the recommendations we have in the National Academy study, where it is really critical that we create some kind of a public-private partnership between the government and the industry to have these conversations. That was a recommendation that we made, because really where all the innovation is happening right now, as opposed to some other emerging technology in the defense sector, for example, all the emerging biotechnology is happening in the private sector. It's happening in companies that are, creating all this new things, from pharmaceuticals through agriculture, through plant science, everything. So the first step is to create this sort of a dynamic public-private partnership where these conversations can begin. And then in specifics to your question, I think there is a lot of opportunity in the wake of COVID-19. There are so many things that we learned about our vulnerabilities in that space that we are going to want to shore up right away. Our vulnerabilities have been exposed in a major way. And so if we want to continue in the vein that good public health and preparedness and response and good response platforms that are secure are the way to deter use of biological agents in the future, then the place we need to start is with public health and shoring up all those systems. So I would say public health and pharma systems might be the place to start with those public-private conversations, but that they could extend to the agriculture sector and others in sort of developing best practices and so forth. That's my quick answer.
Thank you.
Thank you so much, ma'am, for your question. And I will echo what Diane just started as an excellent answer. So public-private partnership, that's obviously key, because indeed most of the knowledge is in the private sector. But I would look at a few examples, success stories that we have seen in the recent past. So one of them, for example, is the International Gene Synthesis Consortium. You've heard about that enterprise in the past. So they do extremely sophisticated functional genomics security screening to be sure that to prevent illicit gene synthesis. That's an example of creating capacity building, economy of scale, and sharing of knowledge, so that the forward-looking, cutting-edge aspect of this industry can talk to each other and figure out new solutions. Could we use that model for integrating, the top knowledge in AI and cybersecurity, for instance? And the CISA, that agency, for example, in the US, is a very good example of doing foresight and doing threat assessment across field and across sector, also in a public-private partnership fashion. So those are two examples that we could have in mind. How do we harness, those forward-looking private sector actors that understand the importance of actually still sharing cutting edge technologies, but doing it with a new model of safety and security at core?
I obviously know one sector is going to give you all the answers, but perhaps a good starting place would be in the synthetic biology community. They are, in general, as a sector, they are more sort of very highly sensitized to issues relating to security. So, for example, the Symbio leaders have been to Biological Weapons Convention meetings, and they contribute a lot to kind of a lot of more traditional biosecurity discussions. And of course, there's something called the International Genetic Engineering Machine Competition, or IGEM. And that runs its own, it's targeted at high school level and university level, and also community labs, young synthetic biologists worldwide. And they have their own very successful safety and security program, which obviously I'm biased because my husband runs that. So, But they, and as part of their program also, they are required, and there are materials on cyberbiosecurity. And a lot of these synthetic biology leaders, they're young and upcoming and dynamic, and they also work very much with iGEM. So I think as a place to go, first, I think they're very open and they are sensitized. So that might be a useful starting point.
Thank you. I yield back.
Thanks, Donna. Cleanup, Ken Weinstein.
Okay, I'll back clean up here and do so quickly. Thank you very much for your presentations and your candid, very thoughtful answers to our questions. I'm just going to ask one sort of kind of high level question, and this goes to an issue we've talked about in this commission, which is, in the aftermath of the COVID pandemic, how do we ensure at a political, societal level that we are sort of corralling the lessons that we've learned of what was done right, what was done wrong of the pandemic, and then sort of helping to kind of bring together the political and public will to devote the resources, time, and effort to addressing whatever failings plagued the response to COVID-19. And so I guess one thing that's been talked about is, whether there should be a commission the style of the 9/11 commission after 9/11 that would take a macro look at what happened and why it happened, and how, where there were strengths and weaknesses in the government's response and society's response in general. And I guess I ask you whether any one of you or more than one of you can respond, whether you think that would be a good mechanism for developing the sort of the will to mount the effort that's needed to address this concern. And do you think as part of that, a commission could look at not only just the pandemic, but also the cyberbio threat that we saw carried out against some of the companies that were developing the vaccine and scrambling to try to meet the needs of society? So I guess open-ended question whether you think that would be a useful exercise and would help provide some momentum to put in place the fixes that we need.
Thank you, sir. I'll go first. So I think one concern I have moving into the timing post-COVID is that we are going to have so many different after actions. We've already seen a lot of dabbling in this space and publications and studies and think tanks and different agencies looking at their own responses. We do have a national biodefense strategy, and my presumption is that folks at the NSC and elsewhere are going to take a careful look and say, how well did we respond? My concern is that amidst so many different takes on the response and different entities putting forward, well, we would recommend this, we would recommend that. A commission might be very helpful in sort of corralling all those after actions and all those lessons learned, as we do in federal government, and sort of putting together something extremely broad and cohesive that could take all of those into account. So I think it has value from that perspective. I think also there are a number of things that, COVID-19 was not a failure of our imagination, right? We've been exercising and planning and worried about pandemics for a long time. And I think that some of the issues that came to light in problems in our response are things that we've allowed to fall by the wayside. So I would say that we need to modernize all our preparedness and response platforms. And a commission could think about ways that are best to modernize those platforms. How do we do better and faster diagnostics and tests, for example, that were so slow? We knew we had to do diagnostics and tests, right? But we didn't use all the latest, greatest, best technology to get there fast. Same thing with our supply chains. We know how supply chains work. We know how logistics work, but we have antiquated supply chains for a biological emergency. And so I think potentially those are two areas right there where, every after action is going to pick on those things. But if you had a commission that looked at them, you could say, how do we generate some enthusiasm about modernizing the things that we've always prepared for, but that didn't perform the way we wanted them to perform in the pandemic?
Thank you so much for your question. I would say that I think what this crisis has demonstrated and what we will see happening in the near future, it's really an increasing trend of convergence and democratization in AI and biosciences, because it's really artificial intelligence that has made a difference in how we optimize biosciences for fast track diagnostics, medical countermeasures, and for surveillance. So I think that's a trend which is a given, which is too powerful for us to refuse. So we need to think about how to secure that trend and how to make safety at the core. So I don't know if a commission is a way to do it. I would reiterate that it's really an enterprise that has to be cross-field, cross-sectors, and forward-leaning, so using foresight. But I think in a way what we learned from that crisis is also three types of tensions. One is about biosovereignty. How do we make sure that that public good approach that we have towards AI and computing forces, how is that something that we also preserve in terms of national security? So that's one tension. Another tension is what I would call biocitizenship. What this crisis revealed is that we need public trust. We need to have, at the core of our social contract, trust into the biosciences. So the next generation of citizens could be part of this revolution of using AI and biotech for good and doing it in a secure and safe way. So like when Catherine mentioned, IGM, there are other decentralized groups. IGM is a good one. That's the next generation helping with building that trust. And then another trend is biopolitics. Increasingly, AI and biological data means we know more about population and we can control them in diverse ways. So how do we think also about the social contract in that sense, preserving human rights and preserving governance that's at the level of our democracies? So we see new tensions, but this has to be a cross-sector and cross-field.
I agree completely with my fellow panelists. Definitely a commission would have some immense value, especially taking on a kind of unjaundiced eye, if that makes any sense, at what went wrong and what went right. This is something that the UK is struggling with right now. They're trying to figure out how to do it and they're not quite sure. And those delays are actually hurting public trust. So and public confidence there. And so I would sort of say that timing is key. It's quite tricky. We're still not out of the COVID woods, certainly not in the UK. And premature assessments could be as harmful as they could be useful. But certainly looking towards how you put that, how you put a commission together, what its aim would be and what it who would be involved as a first step would be great. And then looking towards when is the best time to start bringing in those lessons is really something that does need careful consideration.
Okay, thanks very much for thoughtful answers. Back to you, Senator.
Yeah, thank you, Ken. Incidentally, I was encouraged, and probably all my colleagues saw it, that Senator Susan Collins and Bob Menendez did an op-ed yesterday, I guess, calling for a commission very much like what you just described, Ken. So we'll see what happens with it. I want to thank the panelists. I was just thinking during this panel that after we were a few months into the pandemic last year, I had a conversation, I bet a lot of my colleagues on the commission did too, where somebody said to me, well, they went back and looked at our foundational report of this commission in 2015, and they were just struck by how much we predicted what happened in the COVID-19 pandemic. And I said, look, the members of the commission are a gifted and experienced group, but the only reason we were able to write that report was that we listened to experts in the field who, to use your phrase that comes also from the 9/11 Commission report, Dr. DeOlius, no failure of imagination. The experts imagined based on their expertise what was probably going to happen. And I have the same sense today that, I guess I want to say to you in the most basic sense, thank you for devoting your careers to this field. And thank you for sharing your expertise and your imagination with us this morning. And hopefully we can take it and convey it broadly. And maybe, since we've now been through this pandemic, draw a more preemptive response from our government and from the private sector. Anyway, thank you very much. You've been really helpful, and the risk you've taken is that we will contact you again for more help.
As I welcome my colleagues back, and we welcome this very distinguished third panel as the Commission continues to explore the challenges associated with the convergence of cyber and biological sciences. To that extent, we've got three very interesting perspectives during this panel. The first individual, Dr. Susan Duncan. Susan is the director of the Center for Advanced Innovation in Agriculture at Virginia Tech. And talk a little bit about cyberbiosecurity within the world of agriculture. As a former governor of Pennsylvania, knowing ag was the #1 industry, and obviously it's at the epicenter of our national economy. Anxious to get your perspective in that regard. The second speaker, Dr. Sterling Sawaya, founder and CEO, really interesting company, Gene Infosec. We've been talking, Doctor, in earlier panels about securing the genetic information out there. And we're very interested in your perspective. And finally, Janine Medina, currently a White House Presidential Fellow at BARDA, and brings that perspective, but also the executive director of a very interesting organization called Biohacking Village. We're anxious to learn about that, and then get your three perspectives on the challenges associated with that convergence of the bio and cyber science. So with that introduction, Dr. Duncan will ask if you will initiate the conversation. Thank you.
Thank you, and thank you to all the commissioners for this opportunity to speak to you today, and as well as to the organizers for this invitation. I've already been introduced as a director for the Virginia Tech Center for Advanced Innovation in Agriculture, and I'm also the associate director for the Virginia Agricultural Experiment Station and a professor in the Department of Food Science and Technology. With those three types of backgrounds, I'm bringing to you some perspectives that we have regarding this opportunity for exploring cyberbiosecurity in agriculture and food system. At Virginia Tech, we're one of the few land-grant institutions who's actively engaging in advancing cyberbiosecurity for the food and ag system and the broader life sciences. And we partner with our colleagues in cybersecurity and cyber-physical security. We're very interested in advancing the innovations and technology for agriculture. And with those advances in technology comes the responsibility for security of the biological data as attained as we grow and produce crops, animals, feed, and food, and paying attention to the potential value of those technology and the risks that come with the increased connectivity. Yes, this is what cyberbiosecurity really engages, is at the intersection of biology, digital, cyber, and physical systems. The US food and agricultural system is extremely diverse, very productive, and provides food around the world. The food and ag production sectors influence over 20% of the US economy and 43.3 million jobs. And to meet the expanding population of the world, the farmers will need to produce about 70% more food than what is currently being produced. And this increase will take the new agricultural technologies we're describing, many of which rely on this digital interface, including such topics as artificial intelligence, Internet of Things, the cloud computing, 5G, 6G networking, and more. While these advances are being explored and adopted at many universities and other places for improving agricultural productivity, the rapid rate of new technologies and incorporation into use has not been accompanied by that parallel effort in security measures. Too much rests on our securing the US agriculture and food system, both for domestic security as well as for supporting food and economic security around the world, to ignore the need for cyber biosecurity or delay prioritizing it. Over this past year, probably for the first time in more than 75 years, many Americans experienced firsthand reality of food shortages during the COVID pandemic. This was an emotional event as Americans faced the possibility that food was not or may not be readily available. And this has been the first time that some Americans started thinking about food insecurity. But without providing cyberbiosecurity, it may not be the last. Last month, JBS, which is a major global food producer and supplier of beef and pork, had a ransomware attack against its IT servers. This attack forced JBS to stop its operations in multiple facilities. JBS did pay a ransom of $11 million, but that was not the only cost or the only effect. JBS is a supplier to many other companies that had to search for an alternate supplier or wait for JBS to resume production and distribution. Within the food and beverage industry, the JBS incident is the latest in a spate of ransomware attacks on major companies. For example, in 2017, the cyber attack against Mondelez International resulted in significant operational disruption to its production, distribution, sales, and financial losses of over $100 million. The public now knows that threat actors can disrupt our domestic food supply. With ransomware and other forms of cyber attack comes the risks that affect critical biological process controls, theft of biological data that holds the key to intellectual property, disruption of data identifying pathogens on crop and for food safety, and strategic and competitive advantages. Every farmer and every agribusiness functions as a data scientist, relying on that biological data. They're using technology, but they also know what their data looks like. They know how to make choices based on that information. They want to make the best decisions for their productivity, for their business, and to contribute to the food supply. But these small and moderate-sized agribusinesses also need protection. These agribusinesses most often do not have in-house information technology support or security that is obvious in the large corporate entities. But they also serve as suppliers in mid-chain and end users throughout the food chain, from farm to table, supplying large businesses and direct to sales. Attacks on these companies may be equally disruptive, with significant effects on operational financial losses, not just to their businesses, but to the large corporate entities and others. In a recent conversation with the Information Technology, Information Sharing and Analysis Center, the IT-ISAC, in their Food and Agriculture Special Interest Group, this includes corporate food and agricultural companies. They identified that one of their greatest concerns was the lack of security in the small to medium-sized supplier companies. So I have suggestions to leave this message with. First is that funding is essential to expand awareness and engage key players in this war against cyber attacks on the food and agricultural system. We just can't afford to delay the incorporation of cyberbiosecurity in the food and ag system. Let's not wait 60 years like it took to put seatbelts in cars for us to start putting security into our food and ag and life science programs. To do this, we need more research funding, more educational funding, support for small and moderate-sized businesses to address the gaps in their security. We also need some policies to help support and secure this adoption. These would be valuable, but I've heard that there's not a support for mandated regulations at this time. My second point is that education is necessary at all levels. While we do have cybersecurity strength throughout our nation and in many educational institutions, we have to work in cooperation with researchers, academics, and our gift to the nation, the cooperative extension programs. And through them, we can deliver formal and informal education programming across every state in the nation to nearly all of our food and agricultural stakeholders to develop this baseline awareness and establish entry-level assessments. Funding the land-grant mission of agricultural research and cooperative extension for cyberbiosecurity can help us achieve this goal. One strategy is to use the train-the-trainer model, where academic and cooperative extension specialists provide formal and informal education to extension agents and then direct to stakeholders. By training these specialists and researchers across the nation, we can engage stakeholders and provide workforce training directly into the companies. And thirdly, we need a playbook framework. Just as we had to deal with the pandemic and everyone was at a loss as to how to take the next steps, this is the moment where we need to do the same with cyberbiosecurity. This requires knowledge of the system, the food and ag system, the domain expertise for the sectors within the food and ag system sectors. They need to be engaged. And we also need to work in cooperation with the cybersecurity experts that already exist. By identifying the unique challenges and vulnerabilities for each enterprise, it's not a one-size-fits-all situation. This requires the capacity to understand the nuances, have the trust of the stakeholder, and provide them with guidelines for the next steps towards security. I thank you for your time and attention, and I'm happy to answer any questions when that's the right time.
Thank you, Dr. Duncan. We appreciate that. I'm sure there'll be quite a few questions for you.
Thank you.
Now, with Dr. Sewaya, we are anxious to get your perspective, and the floor is now yours.
Thank you very much. I have some slides to help rest. We could perhaps put those up. Here today to talk to you about the sensitivity of genetic data and the importance of keeping it secure. But we need to keep this genetic data secure from the moment that it's created, and this introduces a problem. Our genetics labs are not just insecure, they're difficult to secure. So genetic data is critical for our advancements in science, but along with these advancements come threats. Some researchers would claim that these threats are merely theoretical. We believe that these threats are actually emerging and things that we need to address head on. For example, our search for our ancestry has created large databases that allow ease of identification of genetic data. And this is a problem because we often simply remove the name from the file and consider that genetic data to be anonymized, when in fact, it does not protect the data. This data contains a large amount of sensitive information about your potential diseases. So this is great for our doctors being able to design pharmaceuticals and design treatments specific to your DNA. But if we consider things like neurodegenerative disease, we have to recognize that there's the potential for adversaries to uncover these diseases and take advantage of them before you or your doctor even recognize that the vulnerability exists. In fact, these vulnerabilities be exploited without your knowledge that they're even exploited. But as we look to the future, we have to consider the threat of bioweapons. This is not simply a threat from it doesn't change during our lifetime. When it gets out there, we have to recognize who might be generating these potential weapons in the future. And due to advances in technology, this opens up the possibility of not just rogue nations, but rogue groups introducing these threats. Next slide. So how do we keep our genetic data secure in the lab? The fact of the matter, it's very difficult. We've done research in this area, some of which has been published in a peer-reviewed journal, more of which will be published this year, and we also have a talk at DEF CON coming up. There's just a number of different areas in the lab in which the data can be stolen. When we look at labs today, we find that there is a lack of security, and due to the number of devices and the lack of security in these devices, this environment is incredibly difficult to secure. Our patent pending solution is molecular cryptography. So what we're proposing here, what we're demonstrating here is relatively simple. First of all, we generate a large number of unique pieces of DNA. With A, T, C, and G, and a relatively small piece of DNA, we could in fact uniquely tag every molecule in the known universe. So we have a lot of randomness to play with here. We collect a group of samples and then uniquely tag each piece of DNA in those samples. Then, after we've pooled those samples together, only individuals that know which tags belong to which sample will be able to decrypt the data. This means that the data that comes off the sequencer that is handled in the lab and then stored on the cloud has been effectively anonymized and secured. Furthermore, there are other advances that we can make in this area, including the use of decoys to add to the pool, uniquely tagged again, to further conceal information, and the development can be added further and further from there. So next slide, please. Now, when we look back at the lab, we can see that all of our data security concerns have been solved. The information is protected before it ever touches a computer. This also allows for secure storage of DNA, which could also mean secure transport of genetic material. So with this, I would make 3 recommendations to the Commission today. First, it's of critical importance that we recognize the identifiability of human DNA and its sensitivity. Our second recommendation is to provide government support for the development of this technology. Government support will speed the development of this technology to make it ready as soon as possible. My final recommendation is that we do everything that we can to improve lab cybersecurity. These labs are our front lines during a pandemic, during a potential bioterror attack, or a bioweapon use. So if they're taken offline, then we're flying blind in a very difficult time. Imagine the COVID-19 pandemic if we had our labs taken offline. And I think the best way to promote cybersecurity in these labs would be to offer grants to labs that are handling sensitive genetic data to help them improve their cybersecurity, potentially to reach something like a NIST standard. So thank you again for allowing me to participate in this panel, and I look forward to the discussion.
All right, Janine Medina.
Thank you for the opportunity to address the Commission this afternoon. As a way of introducing myself, I have worked in the healthcare industry for 16 years, primarily in the New York City hospital systems with electronic medical records and its associated IoT connected devices. I have 2 master's degrees, one in biomedical and health informatics with a focus on data collection and correlation. The other is in translational medicine with a focus on creating new medical devices. And I am currently working on a 3rd master's in international affairs with a focus on warfare. I am a co-founder of the BioISAC, which focuses on the pharmaceutical and biological information sharing. I have served in the United States Marine Corps and sat on the Department of Defense Technology Transfer Board, advising on new technology. I am currently a Presidential Innovation Fellow at Biodefense, and I would also like to state that I do not speak for, nor do my comments or thoughts reflect any of the Presidential Innovation Fellows or Biodefense. So I am the Executive Director of the Biohacking Village, where we focus on biotechnology, biosecurity, and citizen science. I've run this conference for 6 out of its 7 years and have grown it from a fledgling organization of 9 talks and 2 demonstrations to 3 distinctive labs. The device lab, where we focus on medical and pharmaceutical device cybersecurity. We invite manufacturers to bring their devices to our pseudo hospital setup, where they come face to face with the cybersecurity researchers, hacker community, and allow the researchers to test the devices and provide real-time feedback on vulnerabilities and possible fixes for those products. The Speaker Lab invites folks to speak about their research in new and emerging threats to the bioeconomy and how those threats affect the healthcare system, along with solutions and mitigations. The Catalyst Lab allows for researchers to have hands-on training experiences with biological and technical experts to build their knowledge of the entirety of the system. We are also working on creating a pre-seed funding venture capital ecosystem, which will lead them to larger incubators and accelerator programs, and eventually to the FDA Digital Health Center of Excellence, where they can be mentored by medical device professionals and take their products to market. These labs were instantiated to establish a better understanding of the bioeconomy ecosystem. Prior to this, the medical and healthcare system had been shrouded in secrecy and protected by obscurity. The pandemic has exposed the holes in this belief with fascinating alarm. We've come to realize that the biomedical ecosystem is not just relegated to the healthcare industry. It has adjacent sectors and industry verticals, such as social engineering, Internet of Things, infrastructure control systems, the darknet, finance, cryptocurrency, privacy, supply chain, and infrastructure. It is an international issue of data gain and data loss. So the United States is currently in an asymmetric warfare situation with high visibility and low liability, and may lose the battle to control the healthcare economy. The Biden administration is currently releasing executive orders on cybersecurity, national infrastructure, and protecting American sensitive data from foreign adversaries to guide the industries for increased outcomes and progress for better cybersecurity via laws, rules, regulations, policies, audits, metrics, and standards. We at the Biohacking Village have to be brave and not frightened of going into these dangerous and polite places. We are moving forward, creating an environment of trust, transparency, and resilience through communication, working with and for the device manufacturers, and guiding new researchers in this field. My request would be to have more funding to create a standalone evergreen biohacking village where we can create more conversations around this, training, research, and exercises in assisting with the greater care and knowledge of the biomedical ecosystem to maintain the integrity of patient care. Additionally, as Dr. Sawaya and Dr. Duncan said, bringing together more domain expertise that can provide insight into adding resilience to the healthcare field and guiding on those laws, rules, regulations, standard metrics, audits. Thank you, and I welcome your questions.
Well, thank all of you. I'm sure my colleagues will have multiple questions, but I get the opportunity to begin the conversation. Dr. Duncan, you proudly referred to Virginia Tech as a land grant school. There are a lot of those throughout the country. One in Pennsylvania, Penn State, you're probably pretty familiar with in terms of its emphasis on agriculture. But what role do you see these state universities going forward in dealing with the convergence of bioscience and the cyber world? But beyond funding, I mean, do you literally have the kind of intellectual collaboration when you bring the firepower from people such as yourself and other those in the university in a collaborative rather than a competitive environment to address these issues?
That's a great question. I thank you for sharing that concept. Yes, I think that we do. Every land-grant university has collaborations. We have our agriculture experiment station directors come together and talk about priorities within the regions that they exist within, as well as across the nation. We have the same with our Virginia Cooperative Extension, meeting with other cooperative extension directors across the nation. So we understand where these challenges exist. The barrier we're at right now is this domain, this convergence, is not yet well supported with guidance materials to our extension agents and our extension specialists across the nation. So we have a gap there that is really important. When we reach that ability to have each one of them that are working with different stakeholders know the issues, know the challenges, they will be able to answer questions directly. That doesn't replace a consultant who might need to come in and do very detailed assessments, but it gets the awareness to every stakeholder, every person who's touching that food supply, and be able to help them analyze and self-assess so that they can be more informed when it's time to answer questions through a consultant.
Does that universal guidance that you would propose right now, there's a gap, you need that broader guidance. Does it come from a consensus within the educational community? Do you need collaboration or leadership from the Department of Agriculture? I mean, it's a national security issue. I mean, do we get it from inside the National Security Council? So who's the conductor of the orchestra in order to bring all these disparate pieces together to get the guidance you need?
This is great. Yeah, I think it takes all of those entities you mentioned plus more. The reality is that it's going to require some collaboration across agencies first, because this is not a single entity's responsibility, but ultimately it's going to come down to boots on the ground. And that means that we do have to know who's going to engage those boots. And that is being able to, in addition to funding, we'll not put that back on the table, but I'm just saying that USDA has to be involved because they're the ones that are involved. But we also have all of the commodity groups, the major players within each organization, each structure that's talking to each producer group or to each commodity area. We can't allow the private sectors to be independent of this. They need to all be part of the play a part of the system. This past fall, we did, with funding from USDA, we put together a workshop called Safe with Cyberbiosecurity, and it meant securing the agriculture and food economy. We had over 170 participants. They included federal agencies, academia, private industry, state regulatory activities, and they all came together. We talked about where these gaps were, we talked about where the needs were, and everybody comes, the final information that we said was, we know these exist, we know their problems are there. How do we get the ball rolling? And it starts with grassroots and it ends with everybody coming together to do their part. I would suggest that if we're going to have a real strong step forward, USDA as an agency has probably the first lead to the ag and food system, but this is bigger than just food and ag. It's these other biological places as well. So there's other entities that need to be involved.
Thank you, Dr. Duncan. Thank you. Fascinating presentation. I don't know how you were able to do it all. You must get 22 hours worth of effort out of every day and sleep very little. But having said that, this is we tried to make recommendations. We not only tried, we made recommendations 6 years ago to the policymakers vis-a-vis just the threat of a pandemic of this sort. And now we're much more granular. We're taking a look at this convergence of cyber and the bioscience world. With the range of experience that you've had from inside the White House, previous to that, and your the biohacking village, in addition to the funding, I mean, we get all of that. But when you take a look at the significant, in your mind, based on your experience, could you identify the two threats if you had to prioritize, okay? And we all have to do that in our personal and professional lives. How would you prioritize the threats resulting from this kind of convergence? I mean, obviously, Dr. Sawaya talks about just access to genetic information. Dr. Duncan has a point of view. I'm interested in your point of view.
I love this question. So one of my main recommendations for this is there's not a lot of communication from what I've seen within the government of the various agencies that control healthcare. There are about 23 different entities within the government that do this, and they work completely in separate silos until they have to converge and have a conversation. And that's part of the big problem, because if one is regulating, as an example, the FDA only controls the medical devices. And for too long, too many people have had the conversation of devices are the greatest thing, and those are the only threats we have. Coming from the background that I have, where electronic medical records are the central oasis of all of the data. And if I take all of the information from an electronic medical record, I don't necessarily care about the rest of the devices because everything is centralized in there. And the other part, so the reason I look over here is I have a board of thoughts. So the other part of this situation is we are on a daily basis coming across various different ransomwares, different kinds of warfare where they're trying to get the information from us. And I think we have to do much better at figuring out where those are coming from, but more than that, protecting the situation that we're in. As an example, at the Biohacking Village this year, traditionally, we've just had the hacker community working face-to-face with the medical device manufacturers, and coming from the hospital background, there's so much more to this. So we have started instantiating, working with different groups outside of the Biohacking Village and providing a software bill of materials, which was a recent executive order for the manufacturers on the devices that they're bringing, so that they already have that knowledge base set in place. On top of that, we're also giving them threat emulation testing so that, again, they have more insight into their device as it is. During the conference itself, we're going to have a system that sits on top of our pseudo hospital that will collect the logs, and those logs will be sent out to the manufacturer so they can see what's going on. There's another entity that's going to sit on top of our system that is going to ping, that is going to acknowledge all of the devices that are in our system and say, these are the vulnerabilities you have, these are the issues that we're seeing, and send those reports back out to people. And we're also giving them 3 months of free access to all of these things so that they can have continuous knowledge of what's going on. And then we're trying to, additionally, we're also doing tabletop exercises. So we're doing a tabletop exercise with the healthcare ISAC on Thursday, and we're doing a bio-ISAC tabletop exercise on Sunday, so that those manufacturers can, again, have more contact with the hacker community, but also see what's going on with real situational awareness for through the vignettes that we're providing for them.
Quick follow-up before we go back to Dr. Swire. Once you complete these tabletops, great exercise, is there a summary and recommendations that follow that are distributed back out to the group?
We are doing after action reports.
But based on the tabletop, is that information provided to a relevant government agency or agencies? And I realize that across the board, you're talking to the First Secretary of Homeland Security. I understand about verticals and how it's tough to get them to collaborate and work together. But these recommendations, are they disseminated both in the public and the private sector?
They are disseminated on our website, which is free to everyone. The answer is no, we do not independently give it out to people.
I appreciate that. Thank you very much. Dr. Swire, we were talking about the molecular cryptology, where it is in the marketplace, your collaboration, et cetera.
So we definitely need public-private recognition of this problem. There is private interest in the secure methods of sharing and computing genetic information. The lab component has so far not been fully recognized. So we're working today to build those public-private partnerships.
Thank you. Senator Lieberman?
Thank you. Dr. Duncan, let me begin with you. So I think the recent cyber hack of JBS, the meat company, was yet another learning moment for a lot of our society, which is that a meat company is so dependent on the internet that it can be hacked and held up for money, or can actually create a food crisis if one lets one's darker imagination go and sees a company like this as the target of an attack by a hostile nation in the midst of a conflict. So, I mean, to say the obvious, I think we're all learning that whatever you do in our society or in the world these days, if you're connected to the internet, you have a potential cybersecurity problem. And so I guess the question is, and we're way behind generally in reacting to that, and the attackers are ahead of us, of course. So part of what I wanted to ask in terms of this JBS being a teaching moment, and you're in the midst of it, to what extent are people in businesses, individuals in agriculture aware that they're vulnerable to cyber attack, and that it can have a really devastating effect on their livelihoods in the first instance, and then on our food supply right after that?
That's a great question. I think that in a general statement, without any type of large survey to tell me specific details, we do have small surveys here in Virginia that have illustrated that while some of our producer farmers are aware of the need to protect their data, they also are most familiar with just using their home computer, sometimes which has their business aspects on it as well. And they're still allowing perhaps other people within their family unit or their business entities to use that same computer, who may or may not have the same level of integrity or the same level of concern for those security. You know, major entities have amazing IT sectors. They have their experts there as well. But we also find that when you start speaking to other portions of those companies, they're all relying on the IT to do that work. There are still a lot of human factors engaged, and those human factors can introduce susceptibilities, vulnerabilities that, while we've had instruction to not do certain things, it's very an innocent click on a email or a link or an attachment that looks like that's coming from a respected name that they would trust. Conversely, we're also looking at how many of our scientists within these entities, these companies, are thinking about the computerized systems that are connected within that have critical process. So these are processes that could be regulated in terms of management for a critical control point within the food system, that if there was a corruption, a malware that got imposed on the software or that got access to that particular, they could override some of the data systems and actually manipulate the screen output to make it look like it's happening, whereas the thermal process does not get regulated the way we expect, or that the time temperature relationship is not this expectation that we would put in place, or that they've over added or underutilized a sanitation agent. And the screen monitoring may suggest that the data is accurate, that it's very reliable, but we may have something happening behind. And so there's multiple layers of biological assessments that need to be constantly monitored to validate in addition to what the computer output suggests. We cannot just anticipate that the data is truthful, because there are ways for that to be corrupted.
Yeah, well, you had a sentence in your opening statement which really struck me, which was that about mandated regulations, and that I don't remember your exact words, but you said that you were led to believe that that was not possible to achieve. I must tell you that I worked with some colleagues in the Senate 10 years ago to do exactly that, and it was just opposed in a very political way by, I thought, businesses that just didn't want to have to be forced to do that, even though, I mean, they rather run the risk, or some of them buy cyber insurance, and the vulnerability is not only theirs, but it's the rest of our society, because a lot of our critical infrastructure, which I would include the food supply in, is owned by private entities, not by the government. That's the glory of our economic system. So I think we may have to come back to that at some point. It's very hard to expect small agricultural businesses to pay for adequate defense, but we can certainly try to do that with the larger companies. I just say that. I don't know if you want to respond to that in any way, based on your experience.
Sure. In our workshop last fall, when we were asking that question, there were some responses from the corporate entities that were there, and they felt that they owned a responsibility to this question, but they felt that it would be better done by their own integrity, their own motivation, than to have an unfunded mandate. They have a lot of those to deal with. There are a lot of places they have to put labor into regulations, some of which are important and need to be, fully enforced, but others are not being supervised or mandated or enforced, but at the same time just need to be addressed to the point of distraction. And they felt that this is more of, let's own our own responsibility. And that one of the comments that came across, and Asha was at that meeting, so she may be able to echo on this as well, but their comments that I recall were, let us help in the system and help our suppliers and our small business, moderate-sized businesses, entities to also lift it up, but let us kind of lead the way on that. Now, whether that's going to be a full embracing by all of the companies, that's another question, and that's when regulatory pieces come into play. But I do think that they want the privilege of being into doing things correctly and doing it right.
Okay, thanks. That was helpful. Dr. Medina, quick question, and then I'll yield to my colleagues. So do I understand that the Biohacking Village is essentially a conference that you, or educational program you run periodically?
Correct.
Yeah. And who do you hope who comes to it? And I'm just curious about what the, you might say what the curriculum is.
Right. So the conference is held, rephrase. So DEF CON is the conference that runs the entirety of, I see nodding. So DEF CON is the largest hacker conference in North America. Underneath
Right.
DEF CON, sorry?
Yeah, no, I'm with
Okay.
you.
And then underneath that are different villages that focus on the different things. We focus on the bio side. We have manufacturers come, we have researchers come, we've had government officials come, we have foreign entities come. This is the conference of the world, essentially.
Okay, that's great. And what do you hope they get out of it? In other words, do you give them a program to take back with them?
Not necessarily a program to take back with them. So because they can go into the 3 different rooms, they
Right.
have on for everything, and they are able to have the open communication with the speakers, manufacturers, and the workshops. So they take home a lot of knowledge, if nothing else.
Okay, that's great. So I can't resist saying, paraphrasing Secretary Clinton, that these days it may well take a village to protect our society from cyber attacks. Sorry, Governor Ridge, but back to you. It's all yours, Tom. Thank you.
Thank you. I know you couldn't resist. Thank you.
Yeah, sorry.
Dr. Shalala or Tom Daschle. Is Tom still here?
Yeah, yes.
Yeah.
All right, I thought, all right. Senator Daschle. Thank you, Tom.
Actually, who on the panel to direct this question? I'm sure they're all certainly able to do so, but I have to go back to this whole issue of JBS, Colonial. It's been reported that we see now, it's incredible to me, 4,000 attacks, ransomware attacks every single day now, 1 every 11 seconds in the world. And it's become a multi-billion-dollar industry. These ransomware entrepreneurs, if I can call them that, these hackers, it's really incredible to me. And I don't think we have even begun to put the infrastructure in place, nor do we even know how do we address this prolific increase in number of attacks that are occurring now on a daily, not even on a daily basis, on an hourly basis. And it's going to get worse before it gets better. And I would just really love to have your thoughts on what is it we can do from an enforcement point of view, especially to address this. You could call it a pandemic. I mean, it's really extraordinarily serious, and I think it's only going to get worse once we get our arms around it. But I don't think there's much consensus today as to what that ought to look like. How do we go after these people? They're ubiquitous, but they're anonymous. And so I'd love to get any assessment you could give us as to what prospects there are for addressing that, and what in particular would, in your view, be the most effective way to do it.
I don't know the answer to that question, but I will say that one of the things that's really important is that we start young. Several generations ago, people started typing and knowing how to use a keyboard, and then it became that was a requirement. We all had to learn that early in our academic training. Kindergarten, you started knowing how to use a keyboard. Now it's not just knowing how to use it, but actually putting that into some course instruction within our academic training from kindergarten on up of what is cyber hygiene. We know to wash our hands. We also need to know how to interact with the internet, how to use things safely. That's going to change the culture of how Americans perceive the access to the internet, and they'll take that into their work. In terms of what to do on a defense mechanism at the site, I do think it's going to require a lot more within a company to actually put more responsibility on each of us to put our actions into play, to understand what that hygiene looks like, so that as we work on our emails, as we use the internet capacity, that we're only utilizing those streams that have been validated perhaps by the companies for which we work, or by some kind of acknowledged safe areas for how to access things. That won't stop other malicious attacks that sabotage the things we think are safe, but it will reduce some of the unwitting kinds of embarrassing steps that we are taking quite by innocence.
So if I could just clarify, your sense is that really the lion's share of the responsibility is on each of us, that it isn't really a government responsibility as much as it is a personal responsibility?
I think it's a partnership. In my opinion, that if we don't educate ourselves to basically care about our cyber environment, then we are not doing what we can for sustainability. And so there I throw a bunch of words in there that are really catchy and clever, and we'll do it by convergence. Let's do that word too. But the reality is that we could regulate everything and we could go chasing down, whatever clues we have to those criminals. But if we don't put the firewall of personal responsibility in front of that, we're not going to be able, the regulatory aspect is not going to stop this until we have some control over what the innocent issues are.
Yeah. I am going to give what is an unpopular opinion, and at some point you may want to edit this out, honestly. So China has
First Amendment, not a problem. Go ahead.
Yeah.
I am just telling you things. So China has a program, I believe it's called 10,000 points of knowledge or something along those lines. And what they do is they send out folks into the world and they work in certain industries and they glean as much as they can and they take all of that information back to China. And that information gives them an upper hand in this because then they are also given appointments in government as generals, as colonels, as a very high rank, where they can then start dictating whatever information they had and they can start creating oppositional issues for us or wherever else they've gone into the world. The other part of this is that for some of the ransomware, I suspect Colonial, I'm not aware of what their backend code looks like, but I'm pretty sure that it's probably built in old programming language. We have the older programming languages in a lot of our infrastructure. And as such, we might not have the intellectual folks that understand those languages, and they're just building new things on top of it, like Python. So we have that as a possible problem as well. One of the other items that I've recommended before to other folks is bringing the hackers into government and letting them be exactly who they are and protecting the silos and the cybersecurity and whatever it is that the government needs, because once it comes down from the government as the example and the paradigm, it will then be able to shift into private sector.
Well, I thank you for those answers. I guess I still can't quite figure out in my own mind, if we can do all these things with cyber, why we can't go to the source. If we can pay somebody $11 million, you think you could find out who's going to draw that $11 million out of the account and go arrest them, but it doesn't seem that easy. And I haven't been able to figure that part of it out, but I agree completely with the assertion that this has to be a private and a public responsibility, that we have a responsibility to take all the precautions, but I think there really has to be a greater degree of concerted effort to enforce the rules with regard to cyber and go after those who are perpetrating these extraordinarily, increasingly problematic attacks on all of us.
Well, Senator, if I may address that question as well.
Sure. Please.
So from my perspective, this is not simply a software problem or a people problem. This is in fact a hardware problem. And while we are currently working to build our hardware within the country so that we can have security baked into it, and this is a decade away at the soonest. Until that has occurred, we have to accept that our systems are vulnerable. And in as much, we have to recognize that the data on these systems, anything that's connected to the internet, can be stolen. And furthermore, that entire system can also be shut down. So to protect ourselves against ransomware, we need to back up the data, accept that sensitive data be kept off internet connected systems. And in some cases where infrastructure is critical, such as our energy sector, having backup systems that we can replace the ransomware systems with would be a potential solution to preventing things like a week-long shutdown of access to power.
Well, I thank each of our panelists for their thoughtful answers, and really appreciate your contribution to this very important effort. So with that, Governor, I'll turn it back to you.
Thank you very much. Donna Shalala. Donna?
Yeah, thank you. Dr. Duncan, a number of land-grant universities have required cybersecurity training of their staffs. I know UW-Madison, for example, in the School of Agriculture, in the College of Agriculture, has required all the faculty and staff to be trained, I think by July 1st. They actually put a date on it. Though I don't know whether it's just cybersecurity across the board or whether it's really geared to colleges of agriculture. What do you know about this in terms of what the land grants are doing?
I think that I'm going to make a supposition here. I'm assuming that what you're speaking of is really about just kind of that awareness as an employee of being able to manage your own access to the internet, making certain you're using your data systems, you're having all the backups, making certain you know what's appropriate and what's not appropriate actions. I do know that there are a couple universities that are talking and engaging in cyberbiosecurity. Several of those are through the Midwest. There are others that are becoming more familiar and starting to think about it, but it's not been a principal educational content within their courses or within their outreach aspects so far. We were looking at Virginia Cooperative Extension publications and across the nation cooperative extension publications to see if there was anything associated with cyberbiosecurity and even just cybersecurity as the wording. And it's just not out there for people in the general public, the farming communities, agricultural systems, to find that general information. They can find things online. There are research publications that are emerging, but we're still less than 500 research publications associated with the term cyberbiosecurity or bio-cybersecurity. That's in contrast to the thousands and hundreds of thousands that exist in the cybersecurity space. The biology piece just has not yet been a common piece of information.
Okay, thank you. Dr. Sawaya, what's the difference between quantum cryptology and the molecular cryptology that you're talking about? Because we've always used some quantum key distribution to protect medical records for 100 years. So explain the difference between what you're talking about and what's already gone on, because there's a whole literature that has been going on for 20 years or so in terms of quantum cryptology.
Thank you for the question. What we're doing is we're actually using chemistry to generate our cryptography. And although there are quantum aspects to chemistry, it adds an entirely new level. When we're dealing with anything electronic, we have to recognize that there are a number of information challenges there related to the electromagnetic spectrum, for example, and the fact that these are often connected to both power sources and the internet. When we're working with molecules, we're working in a test tube, which means that the information is entirely in that test tube until it has been extracted. So we can apply these cryptographic methods in molecules and do amazing things at a whole new level. And this level of cryptography is interoperable with these other systems. So we can always add those additional layers of encryption on top once it reaches the computer systems.
And what's the shelf life of that encryption of the molecular cryptology? Because we know a lot about the quantum cryptology shelf life. I mean, how long will it last?
As in, how long will it be able to not be broken by
Yes.
by a better computer? Yeah, that's an excellent question. And the way that computer encryption works gives it the ability for a stronger computer to attack it. When we're working with molecules, we are working with the randomness of nature, which means that we don't run into the same problems. So this allows us to not have to be concerned about advances in computing overcoming our encryption method.
Because right now, good quantum cryptology can last for 100 years. So you're basically saying you can't break into it?
I'm not saying every system has its own.
Because I'm going to ask Ms. Medina whether she can break into it.
We'd like to see her try. We also have a great team as well. The way that the way that encryption works on a computer essentially is you sort of have a key, and then once you've used that key, everything is unlocked. So and so if you can figure out how that key might have been made and pick that lock, then you've got one method to convert the encrypted data into something that makes sense. In contrast, when we're dealing with molecular encryption, we're looking at a method in which chemistry makes all of this randomness, and then there's a very complicated key that unlocks pieces of that randomness. So there is no one method where you can just flip the file and convert it into something that makes sense. It's a bunch of nonsense, and if you don't have these keys, it remains a bunch of nonsense and can't be defeated through quantum computing.
Ms. Medina, are you impressed?
I am always surprised and impressed by Sterling. So yes, I have heard, I suspect, what is the foundation for something very similar to what Sterling is talking about. It was someone that had encrypted data onto DNA and was able to transport himself on an airplane, got across the country, did things, went to another lab, was able to pull out the same code that he had put into himself. This is also the first time that I've heard of the background of Sterling's instrumentation. So I am not saying it's not impossible to do. I am saying that there's probably a great commitment of time and energy to undo his work.
Tell me a little about the hackers that you attract, because a lot of the hackers I know are deeply embedded and wouldn't be going to a conference of any kind. So talk a little about the level of hackers and the level of sophistication of your group.
So the part of the glory of DEF CON is that it is an all cash conference. So your name is not connected to anything that you do there. Also, a lot of us have pseudonames. Janine is my real name. That is not the name that anyone calls me when I am during the biohacking village things. The village and the conference bring together a lot of the elite in the hacking community. It also brings in the novices, and there are relationships forged there that bring folks from being absolute beginners. They go to one of the other villages is called Wall of Sheep. Essentially, what DEF CON is a training ground in 3 days, 3 or 4 days, of all of the hacking areas in cybersecurity. So you can leave with a good amount of knowledge and upgrade your level of sec.
Yeah, thank you. I yield back.
Thank you very much, Donna. Ken, are you with us?
First, as to all of you all, thank you very much for your presentations. It's fascinating. And Ms. Medina, I think you get the award for like the most interesting labels to things. Did you just say that there was one group called the Wall of Sheep? Is that what I heard?
One of the villages is called Wall of Sheep.
Okay, just curious, why the Wall of Sheep?
It's the novices. It's the sheep are following the shepherd.
Okay. I love it. And then the other was your reference, and you're turning your head over to the board of thoughts, which I thought was great. So oftentimes I'm without thoughts, so I might borrow your board at some point.
It's a chalkboard. You're welcome to it.
It's a great idea. I wanted to follow up with you. You mentioned earlier two things that were intriguing. One, you talked about the exercises that you all are doing, and then you talked about that you were heading up the ISAC, BioISAC. Could you, and we talked about this with an earlier panel today, sort of the need for that kind of integration and coordination, in all areas, but in particular in this area, and making sure that to the extent that people get indicia of current threats, those indicia are shared among others so that we can build common defenses. So would you give us an assessment of how strong that ISAC is, how it's building, where you see it going, what the prognosis is for it being the mechanism for sharing that information, which is so critical that it gets disseminated?
So I will start talking about the ISAC and then the exercises.
Okay, and then I just want to hear about the exercise too. Thank you.
So the Information Sharing and Analysis Center, we brought it about because there is another ISAC that focuses a lot more on the medical devices in the EMRs, and a couple of the manufacturers from the pharma and the bio side were not necessarily getting the information that was required for them to better protect what they're working on. So it is still a fledgling organization. We are currently working on disclosures, coordinated disclosures, incident response. We are currently working with an organization on better resilience from an attack that they sustained recently. I think that is currently all that I can share about that, because we are still, again, forming. The exercises that we're doing at the Biohacking Village are to bring to bear more of the knowledge from the outside into the medical device manufacturers and pharma bio. Traditionally, they are held and time runs out, and people don't necessarily get the full and complete impact of the vignettes. The person that is currently building them for us is a former lieutenant colonel of the Marine Corps, a wonderful friend of mine. And he has built these vignettes to the point where people are going to perhaps be very emotional because of the information and situational awareness that they're going to be cognizant of. So the exercises are not meant to condone anyone. They are not meant to tell everyone we told you this was going to happen. It's more that they feel their feelings and take the information back to their organizations and say, we need to shore up or we need to fix whatever is going on.
Thanks very much. Appreciate that.
Jim Greenwood.
Thank you. So I'd like to turn back to Dr. Sawaya. I've spent the last 16 years of my life in biotechnology, but I'm not a scientist. But I am intrigued by this whole notion of molecular cryptography, and so I need you to dumb it down a little bit for me. So if you could give me an example or two of an end user. You talked about looking at the universe of genomes. I think you used that phrase, which seems like it's almost an infinite universe, but probably not. And then being able to put unique tags, coded tags in each one of them. So give me an example of an end user who would use this technology, and how would it work, and what would the benefit be?
Thank you, Jim. An example here would be anybody collecting genetic data on, say, a human population. And today, the way that it's collected is we would essentially have your genome in one file and somebody else's genome in the other file. With our method, we would have a file that contains all of the sequences that are produced from everybody in that pool. And those sequences also have error in them. So when we sequence your DNA, for example, we have to, in fact, read it 30 times to be able to ensure that we've got the correct data, because the sequencer itself has error. This is a problem for biotechnology, but a great thing for our technology, for our encryption technology, because when you have a jumbled group of files of a bunch of sequences and you don't even know how many people are in that file, that data then no longer becomes identifiable, for example. It also, with the use of decoys, so if we start throwing other molecules in there, then that data no longer holds health information. as well. And so we go from a data set that from its inception is full of sensitive information to a data set that we can say has been generated. Was that clear?
And does it become the task or the responsibility of the entity that is storing that data to do the cryptography, or is it somehow, do I have control over that?
This entirely depends on how the cryptography is implemented, and it certainly in some implementations, the individual would have control over how their data is used.
Okay, I think I'll yield back, Governor.
Yeah, thank you very much, Jim. Any further questions from my colleagues? I must say this third panel has been beyond interesting, very provocative in a very, very positive way. On behalf of my colleagues, I want to thank you. Don't be surprised if we knock on your door again, because you've opened a couple of other areas down the road. So Senator Lieberman, back to you.
Thanks, Tom. I think, correct me if we take a break now, but I wanted to say to Ms. Medina that what she said after the warning that she was going to say something risky that we might want to erase, every member of this commission has said things much more provocative and offensive than you said at that point. So have no fear. I was struck that your communication with us was interrupted after you said that, and I don't want to point fingers at any foreign power. So welcome to the three panelists on this fourth panel of the day for us. You have a challenge before you, because I would say in one way or another, the previous three panels have given us testimony that ranged between the sobering and the absolutely alarming and terrifying. So now we turn to you for the beginning of solutions. Panel 4 is the role of government in securing the future. We have one governmental official, two experts who will discuss the role of the federal, state, local, and tribal and territorial governments in safeguarding our communities against current and future cyber biological threats and vulnerabilities. We're very pleased to have Dr. Suzanne Schwartz, Director of the Office of Strategic Partnerships and Technology Innovation at the Food and Drug Administration. Also pleased to have, and sir, correct me if I don't get the right pronunciation, I would say Charles Fracchia, is that right?
It's Fracchia, like a K.
Fracchia, okay. Founder and CEO of BioBright, who will offer a private sector perspective. And Brian Ware, who is only temporarily a private citizen, but formerly served as the Assistant Director for Cybersecurity at the Cybersecurity and Infrastructure Security Agency at the Department of Homeland Security. So he brings a lot of very relevant experience to this. We welcome you all. We'll hear testimony from the three of you, and then the commission will ask you some questions. Mr. Fracchia, why don't you proceed, and let's hope all systems are go throughout your remarks.
All right, thank you very much, everybody. Thank you for the opportunity to address the commission today. I am the founder and CEO of a biotechnology and bioinformatics company based in Boston. I started my company following what I would call a gentle encouragement by a program manager at DARPA, who suggested that I drop out of my PhD between MIT and Harvard Medical School to maximize the impact of my research and transition it to an industrial setting. At the time, I was a lone voice pushing for strong cybersecurity in bioinformatics systems, and DARPA supported me and my company. As a result, we built what is still to date the only end-to-end encrypted data collection and analysis system in the field. The system is now commercially available and has been deployed at biotech and pharma companies around the world, securing their data and operations. In this capacity, my team and I have identified and responsibly disclosed numerous critical vulnerabilities to systems that underpin our bioeconomy. More recently, I co-founded the BioISAC, an information sharing and analysis center focused on the bioeconomy. ISACs are important organizations that help private sector companies share threat information and even train the necessary workforce. The BioISAC is now up and running and has already been hard at work collecting threat information from, unfortunately, very active attack campaigns in this sector. It is in both of these capacities that I have seen and analyzed some of the most critical systems to our bioeconomy, from vaccine manufacturing to agricultural resilience, food safety systems, and even emerging fields like synthetic biology and performance biological materials. And this is the reason I'm here today, to sound the alarm about the fragility of our bioeconomy and the existential threats to its future competitiveness. At present, I believe that we are gambling the entire US bioeconomy on a daily basis. We are vulnerable to attacks that can wipe out the vast majority of vaccine manufacturing capabilities virtually overnight. And worse, some attacks that can sow long-lasting distrust in American biologically manufactured products. Our adversaries not only have shown the capability to do so, but also the willingness to attack us and our allies in this way. While the headlines today are of the Colonial Pipeline shutting down or a medical practice in Florida closing its doors permanently following a ransomware attack, many of the same attacks are happening across the bioeconomy privately, dealing devastating blows to our domestic and our allies' bioeconomy infrastructure. Unfortunately, the COVID-19 crisis has only accelerated this trend and increased the number of actors partaking in these attacks. While I must remain vague on the details in this setting, please understand that the situation is truly dire, that we are mortally vulnerable, and that we must rapidly and decisively tackle this issue. We must also avoid repeating all of the same mistakes we have made over the last few decades in the power distribution industry and with healthcare cybersecurity. We must help relevant US government agencies develop a core competency in digital biosecurity. We must promote the workforce development in this sector. And C, create and leverage public-private partnerships to seed the development of defensive solutions. It is my opinion that in order to be successful in this endeavor, we recognize that public and private sectors will need to work closely together. This is not just any other industry. It is critical infrastructure, and the current vulnerability of the sector is simply not acceptable. So where does this leave us in terms of solutions? I, for one, am optimistic about what we can achieve and the future of our country's bioeconomy. While I have much more granular and detailed lists of actions to be taken, I've summarized them here in 5 core points. First, the US government must urgently fund the review and analysis of key infrastructural components of the bioeconomy. We must ensure that these efforts are significantly expanded from where they stand currently. The current level of effort in this area is woefully inadequate. These are successes, but we must have a lot more of them. It is particularly important that BARDA and ASPR build this core competency in the shortest delays. FDA must also expand its approach to other centers, including the Center for Biological Evaluation and Research, CBER, Center for Drug Evaluation and Research, CDER, as well as the Food Safety and Veterinary Medicine offices. Cybersecurity is now to biosecurity, and we must adapt to this new reality. 3, we must catalyze the creation of a skilled workforce. I believe that ASPR should create a pandemic corps, a yearly cohort of workers from the public and private sectors who are trained in key techniques and can be called to serve in time of ASPR could work with non-profit organizations, biohacking, up-to-date digital security, biosecurity education, and preparedness to future pandemics or key infrastructure. Fortunately, there's growing activity in this space, and we can rapidly succeed in this endeavor. For example, my company is working with Pacific Northwest National Laboratories to create an educational hackathon event that will take place later this summer, aimed at bridging the educational and skills gap between cyber and bio. The BioISAC will also be holding a digital biosecurity tabletop exercise in August as well to help sensitize and prepare industry to the cyber attacks that we have seen. 4, the public sector must fund digital biodefense. COVID-19 unfortunately led to a quantum leap in attacker activity in this sector, and we have too few defense tools. Actors that want to defend themselves, however few they may be, simply cannot find the tools to do so. And we are at a critical junction for the bioeconomy. The way we respond now will be a key determining factors in the success or failure of the US bioeconomy on the global stage. I have direct knowledge of both successful and unsuccessful public-private partnerships in this sector, which can be discussed in a separate setting. 5, we must update guidance and regulations to incentivize and promote digital biosecurity in the industry. This must be done in 2 ways. A, HHS must start requiring progressively more cybersecured and verified system. HHS agencies must also update its guidance and regulations around the definition of biopharmaceutical quality to incorporate these new digital biosecurity threats. B, the Department of Defense must update its acquisition rules to help usher a necessary improvement in the security of the systems they procure and use. So I want to conclude my remarks by thanking the committee for this opportunity to talk with you today. What I would like you to take away from my comments today are that urgent action is needed if we want to maintain a dominant position in the global bioeconomy. We need to invest in its defense because right now, many of us are fighting forest fires with water balloons. We have the means, the talent, and the enterprising spirit to do it. We just have to work together to make it happen. Thank you.
Thanks, Mr. Frecke. That was, well, first off, it was a wonderful story at the beginning about DARPA encouraging you to come out. I hope you go back and get your PhD at some point. I'm speaking on behalf of your parents and family, who I'm sure would like to have a doctor in the family. But secondly, you were very direct, straight talking about the thread here. And however, you didn't stop there. You were good enough to offer us some solutions. So I appreciate it. I have a lot of questions I'll come back to you with after we finish the other witnesses. Brian Ware, again, formerly Assistant Director at CISA. Thanks very much for being with us. We're really looking forward to your testimony now.
Thank you, Senator Lieberman. And I don't know how short my tenure will be in industry. This is kind of where I feel like I belong. But I'm proud to serve my country, leading the cyber defense mission for the U.S. at CISA. The company I started actually is a company called Next5, and we're focused on the technologies that we believe will change the world, will be the most important technologies in the world 5 years from now. So taking a 5-year look ahead, we're covering 12 technologies and 3 cross-cutting risk factors: the cybersecurity risks, supply chain risks, and geopolitical risks, which are things with like trade and sanctions and similar risks that will affect those technologies, accelerate those technologies or limit them in some way, certainly from a US perspective. Biotechnology is clearly one of the technologies that we are covering, and arguably one of the most important, maybe the most important of those technologies on that 5-year horizon. Biotechnology also, of course, is one in which the United States is the clear global winner, global leader. Biotech accounts for, on the order of 5% of US GDP, which makes it a larger industry than semiconductors and others that are receiving a lot of attention right now in the United States. And I don't say that to diminish the focus that we should have on other areas of critical infrastructure, but really just, I think we're in a unique moment in time where we can see how important our leadership is there and how important this sector is to the US economy, to US national security, and really to the place of the United States in the world, in the free world. I had the privilege of serving through the early parts of the pandemic up until November of last year. And I want to share with you a few lessons that I think that I've learned from that pandemic as it relates to the biotech sector as well as to cybersecurity. I think there's some lessons here that we need to really carefully consider and to leverage as we plan for the future. So, the first thing I say is that these vaccines, these largely United States developed vaccines, were critical to life returning to some semblance of normal. And we're still meeting over Zoom, but we're increasingly back to our normal lives. We cannot diminish that criticality. Let us not forget how critical that vaccine is to jumpstarting our economy, returning to travel, and all of those things. I think the second thing, just related to that, we U.S. companies, the U.S. government agencies that support them, were able to sequence, research, design, and produce at record speeds these vaccines that experts, like real experts, believed were impossible even a year ago. So, what does that tell us? It tells us that when we put our minds to it, when we take a whole of nation approach, when we find clever ways to use things like the Defense Production Act, or clever ways to bring the Department of Defense and Health and Human Services together with industry, that we can do amazing things that can change the world. I think it also tells us, though, that sometimes technology is evolving at a pace that we don't really understand. If we look back even just short distances, 5 years ago, things that were impossible 5 years ago are possible and tractable now. That rapid technology change presents so much opportunity, but it also requires, that we protect it and that we use it appropriately. I think the third lesson about the pandemic is that the geopolitical implications of these vaccines are enormous, and we are still going to feel out how enormous they are. As the virus in many parts of the world continues to claim lives, it's shuttered economies, it's halted trade, it's halted travel. The vaccine became the essential tool for recovery, but our ability to export that vaccine globally to impoverished nations, to our allies and others, has enormous diplomatic benefit that come with it. And by the way, diplomatic opportunities and responsibilities. And I would just say that had the vaccines, the most successful vaccines at scale, been developed in China, I think we would have seen a different way that they would have used those vaccines to push their diplomatic agenda in ways that may not have been favorable to the United States, certainly, but to the rest of the world as well. So again, I can't overstress how important we've learned that biotechnology is, how critical it is. At the same time that we've learned all of those things, we've also learned that our adversaries had intense and continue to have intense interests in our R&D efforts. Charles, I think, spoke to that really well just a moment ago. Conducting economic espionage, certainly to understand how the United States was thinking, to understand where we were in timing, how far ahead of them or behind them we may have been. Second thing I think that we've seen just recently, not only in the healthcare field, but more broadly, is that ransomware, that other denial of service attacks, and let's not forget in the not so distant past, not Petya, which affected Merck as well as Maersk and others, can cripple industries, it can cripple production lines, it can cripple whole companies. These tools on the offensive side clearly do not require the sophistication of the most sophisticated state actors to have disproportionate impacts on, again, this critical and vital part of our economy. I think the third thing that we've learned is that, unfortunately, our supply chains are incredibly brittle. They're regionally concentrated, and we have limited capacity in the overall global supply chain to surge during times of peak need. Again, we're seeing policy efforts right now to address those supply chain resilience issues, and I think that they are long overdue and certainly welcome. I think nothing like this pandemic and how hard it was to get something as simple as a cloth face mask, much less something like chemical precursors or whatever, needles, have shown us how important supply chains really are, and we have to take those seriously. So to the point of this of this forum, what are some things that government has done, can do, should do in the future? What should we look to? We need to continue some important programs like the security partnership that was built under what was called the security and assurance part of Operation Warp Speed. In that part of the program, we found new ways to share classified intelligence with pharmaceutical companies, to bring them into our offices and tell them what the Russians and the Chinese were doing to them in the ways of conducting espionage. That increased information sharing helped those large companies to know what to be on the lookout for, to better prepare. And we had an open door with them where they could share information that they were seeing with us as well. We had some messaging campaigns as well with our adversaries that let them know that disruptions or denial of service, ways that they impact our supply chains, would be ones that we would treat with the utmost seriousness, and that we would look to impose costs on adversaries who did engage. That kind of proactive messaging is something I think that we don't do all that often. We probably can't do it all that often in every case. But I think that it was really, I believe it was important to maintaining some kind of norms in that area. I think we need to realize also that the sector-specific agencies, I saw Governor Ridge here earlier, Secretary Ridge, this concept that goes back to the formation of the Department of Homeland Security, of having agencies that were the experts in their subject matter. It is still a good concept, but we need to understand that SSAs like Health and Human Services are not likely to be cybersecurity experts. And so we need to continue, as the Cyberspace Solarium Commission indicated, to ensure that those SSAs take their medical knowledge, in the case of HHS, and partner with CISA and their cyber knowledge to provide the cyber protections for that industry. Fourth, we've got to build partnerships and really commit to our partnerships. We built something called the Transatlantic Partnership during the development of this vaccine, where we knew that US companies are multinational companies with multinational supply chains, which means that we have partners in Germany and Switzerland and France and the UK and Canada that help us put extra eyes on what the adversary is doing and provide additional protections. We try to transition the spending that we put into CISA to protect the .gov into protecting companies and critical infrastructure. We try to do that, but I just want to say that the solutions for government don't usually work in industry, certainly not the small contract manufacturers. They may work to some degree to help a Merck or a Johnson & Johnson, AstraZeneca, but the smaller companies don't have the ability to just take the kind of tips that we had on the government side. And so I think when I look at CISA's cybersecurity budget, 90+% of that is focused on the .gov. The next largest chunk, which is single digits, is focused on state and local. And there's a really small chunk of the budget that's really committed to the private sector. And with their importance, not just in biotech, but more broadly, we're going to have to tailor things and build things and focus on the needs of that systemically important critical infrastructure. And then last but not least, and this is a topic that I don't like to get into too much personally, because I don't believe that I'm an expert here, but we can't talk about cybersecurity and biotech, and in particular me talking now about what we learned through COVID-19, without realizing the disinformation and misinformation campaigns are tools that our adversaries like. They've found success there. And campaigns that diminish the perceptions of whether there is a real virus or whether the vaccines will work or are safe. We've seen those campaigns in the United States and elsewhere abroad, and they do nothing short of cost lives, cost us time, but conceivably they could cost the brands of important companies or the stature of our government or our government agencies. And so we need to pay attention to disinformation campaigns as well. And that, I think, will conclude my prepared remarks, Senator. Thank you.
Thank you, Mr. Ware. That was excellent. Dr. Schwartz, why don't you proceed? We're glad to have you back.
I think the best way for me to proceed right now is I'd like to extend upon the comments that Mr. Ware had offered, because there's some recurring themes that are going to tie into us at FDA. And then I'll come around more specifically to what would have been my opening remarks. Brian talked a bit about the criticality of the vaccine as an asset, as a tool that, of course, is going to be that vehicle to get us out of the pandemic. I think what's important to consider as we talk about technologies and as we talk about things like vaccines is not merely the data aspects, the information technology components, but the operational aspects of security as well. And that's where we see a very important confluence that does often get missed in public discourse, where people think of security in this very, IT realm, whereas where we, particularly at CDRH, at the Center for Devices, think about security goes well beyond, the data aspects. Yes, there's the classical triad of CIA, the confidentiality, integrity, and availability. And one can view that through a narrow lens of data, or one can consider that more broadly in a wider aperture in terms of functionality. So in terms of the security of, for example, a device, not only the integrity of data that it might have in transit, but the integrity of the performance and the function of that device and how it could be disrupted as a result of a cyber attack. Similarly, availability. We talk about availability of data, which is critical within the healthcare space. But let's talk also about what's occurred, not theoretical, but for real, with respect to different cyber attacks or ransomware attacks on institutions of healthcare, where availability of that device is no longer accessible. It's rendered inoperable. It's taken offline. And considering these components of the cyber physical realm is critical, but again, it gets often missed in this discourse. So I want to come back to the vaccine example where critical asset, an element of it that did not get much discussion is the cold chain storage aspect of that supply chain and the necessity to ensure that one can maintain that temperature throughout the entire supply chain from the place of development and manufacture that device all the way through the supply chain, last mile to distribution. All of those components right now are monitored and are further operated by computerized systems today, computerized systems that can be vulnerable to different types of exploits or attacks. And that extends even beyond vaccines to all of the supply chain that certainly COVID-19 as a pandemic response has shined a very bright light on, from some of the different types of technologies and devices all the way out through, again, their delivery on site. The importance of considering the security of the supply chain and the security of the software involved in that supply chain has to be part of that discussion. We can't parse these out into entirely separate or siloed issues. And this is what we have been working on, to come back to FDA. Certainly, this is what we've been working on the medical device side for several years already, really taking the long view of what we call the total product life cycle, from the pre-market end in terms of the need for security by design being built into a device, the transparency around the software components in the device, often third-party components, which may have various vulnerabilities associated with them. And yet, if that is not transparent to what will be the customer or the end user, whether it's a patient, a clinical provider, a healthcare organization, then that leaves those institutions, which are all part of healthcare and public health sectors, critical infrastructure, very much vulnerable to various risks. So let's bring this now actually even forward to the executive order that was just released several weeks ago. And this executive order puts, again, a focus on the importance of cybersecurity of software and of the supply chain, and makes some very, very critical points in terms of what is necessary to further advance and to make more robust the security, not only within the federal government, but as a result of that, our expectation is that it will further disperse into the private sector, into industry, as a result of the fact that you have the power of the purse here. By these different products needing to have cybersecurity built in at the level, at standards that need to be established for critical software, that will actually raise the level or raise the bar of what will be used not only through federal government procurement, and we see this within healthcare, whether it's organizations such as the Indian Health Service, whether it's the NIH, whether it's the VA. We have quite a few institutions of healthcare within the federal government that will be procuring and maintaining these devices. So FDA is very eager to work together with our government partners, be it NIST, whether it's Department of Commerce's NTIA, which has an effort around software bill of materials, which we are very much in support of. We also have an initiative around SBOM, as well as, of course, with our partners in CISA. To Mr. Ware's point, while we do have domain expertise in the area of medical, biomedical engineering, and cybersecurity, clearly it's going to be important to develop these partnerships and to collaborate across our government partners to further inform how to advance cybersecurity within the healthcare space. The last point that I really want to make, and I know that we're running a little bit long here, so perhaps more will come through Q&A. The last point that I wanted to kind of make is that, again, the pandemic, COVID-19, really brought to the surface where technologies are going today in terms of the healthcare space, because it really forced the hand as far as a lot of remote telehealth, the ability to utilize or to leverage different medical technologies that do not require the direct interaction, the physical interaction necessarily between provider and patient. And we are seeing that much more reliance or dependence upon these types of technologies as we further advance healthcare and the technology space in general. It makes it that much more critical that as these technologies do further advance, that they do so not only in terms of the brilliance of what they provide in healthcare that just simply wasn't available years back, but through their connectivity with other devices and systems, through their interoperability, that they also maintain a higher level of security so as not to leave vulnerabilities within, again, the ecosystem. And I'll stop there for now.
Sorry, thanks, Dr. Schwartz. That was excellent. Let me begin by asking you to make the cyber biosecurity threat to medical devices a bit more real to us by telling us what could happen here. In other words, would this be an inadvertent compromising of the cyber system on which a medical device relies, or would it be an intentional hostile act against our country in the midst of a conflict to incapacitate medical devices and the people who depend on them. So what are the
Yes.
scenarios that you're dealing with?
And it's either or both, I should say. There are scenarios that we have to be prepared for as a nation in terms of the potential for a malicious, intentional attack by a nation state. And clearly that can happen. More likely from what we have seen in the past is opportunistic, which is there are cyber criminals. They're looking to get information that can be monetized. In doing so, devices or other technologies that are sitting on systems that have vulnerabilities can get knocked off in terms of their performance. What does that translate to in terms of disruption? That can translate to infusion pumps not working. That can translate to, and it has translated to in WannaCry as an example, going back to 2017, which thankfully did not affect the US as much as it did UK, but it did affect certain healthcare institutions in the US where imaging devices, CT scans, MRIs, not available, not working. So picture a scenario where, certainly hospitals, level 1 hospitals that require that patients are going to come in by ambulance. They need to have an imaging study in order to determine whether it's a traumatic injury, whether it's a disease that requires rather immediate emergent intervention, and not having that device, that CT, that MRI available. That delay in service, or that need to then divert ambulances, which we're seeing now happen with ransomware attacks, to other institutions, that delay is costly for a patient. It can be costly in terms of complications. At the worst, it could be costly in terms of mortality. So we've seen that with various ransomware attacks. We do know, as we consider the scenarios around medical device vulnerabilities, whether it's a third-party software or whether it's intrinsic to the device itself, that if the vulnerability can be exploited, then the device may not perform not only at all, or may perform in a way that it should not perform. So the infusion pump example would be to dump an entire delivery of what are the contents of a IV intravenous medication all at once. And one can imagine how that can create a catastrophic situation, not only for a single patient, but because these pumps are connected to libraries, essentially, that for dose deliveries, it can go across a multitude of patients. So it may not be a single patient attack, but we consider in the scenario, as we evaluate vulnerabilities of devices, a multi-patient attack. This could be on an implanted device, a cardiac device. So there's multiple examples I can provide. Okay,
you've made it all too real. So thanks for that. Alarming, really. Mr. Ware, the question I was going to ask you, I was really intrigued by your final point, because as a country now, we're dealing with what seems to be a hardcore minority of our population, but a significant percentage that doesn't want to get the vaccine. And that has consequences for all of us. Do you think, Mr. Ware, that part of that is the result of a disinformation campaign by some adversary of ours?
Senator, I don't have specific information right now to indicate that that was specifically the campaign of an adversary.
Right.
What I would say is that it's certainly consistent with what our adversaries have done in other disinformation and misinformation campaigns. Yeah. And the tools that they use to do that are social media and other things. Are the sources of information that many of those who are don't trust vaccines or don't trust the government's actions to contain the virus. Those are the tools that they look to. And so, I think we just need to be aware that these kinds of activities are oftentimes chained together. That espionage isn't just for the purpose of stealing things for competitive advantage. It may be to early lab results, to create messages, to sow uncertainty, and then to use their tools to kind of proliferate those messages. I believe that because we've missed opportunities for proactive messaging, because there were other negative messaging about this virus or the vaccines themselves, that lives ultimately were lost that could have taken a vaccination earlier, and lives will continue to be lost for those that don't take the vaccine. We need to look at this small. You're right. Right now, we are dealing with a minority of Americans, potentially other countries that have. There are certainly many other countries that have more resistance than we've had here to taking vaccines that they didn't develop inside of their countries, that are coming from the U.S. or coming from somewhere else. We need to look carefully at that and what it might tell us about future pandemic response or future medicines. And by the way, not just from a government standpoint or the standpoint of a citizen, but there's real risk to large brands. CEOs and companies have a risk that I don't want to dissuade them from jumping into these important efforts if they were worried that it could compromise their brand integrity.
Okay, that's a very helpful answer. Donna, Shalala, do I understand you have to leave soon? If you do, I wonder whether Governor Ridge would yield to you for a question or two if you have it.
I do. Thank you to both of you. A quick question to Dr. Schwartz. I follow FDA pretty carefully, and one of the things I've noticed, everybody talks about emergency use authorization for vaccines, but in medical devices, we've also seen an increase. And I was wondering whether that's COVID related and what the lessons of that is.
Thank you. Yes, we have on the medical device side issued quite a few emergency use authorizations during COVID-19.
Whoops.
Yeah.
I think they need to issue one for their computers.
Yeah. I haven't been on a meeting yet in the last 15 months that has had this many interruptions. I hope it's not an adversary. Go ahead, Donna, if you have a question for somebody else.
Yeah, for Brian Ware, actually in the biotech area, whether he has a quick response on what's a major learning from COVID from a biotech point of view?
Probably two things jump out at me, Representative Shalala. We think about Johnson & Johnson as a great American company, but it manufactures all over the world and sources from all over the world and has subsidiaries all over the world. And I pick on them. It's true of all of our great biotech companies. For us to effectively engage with them, we need to be engaging on a global basis. And we need to be engaging with side by side with our European and North American partners. That's one. I think the second thing, and this is just a bit of a surprise to me, but probably won't surprise my colleagues that spent more time on the medical side. I'm used to protecting secrets. I'm used to, your technology is your lifeblood and you do everything that you can to protect it. When we began to engage with pharma companies about protecting the vaccine, there were some executives from some very large companies that weren't particularly concerned about that, because they thought it may actually be a greater good to the world if those vaccine secrets were more broadly available. That was a bit of a surprise. It's something that I think we could use a little bit more government to industry exchange of what we think are secrets that we should protect and when we should share secrets and under what conditions, because we never want to normalize espionage and intellectual property theft. So
I wonder whether that has, I wonder whether that has a lot to do with the fact the margins on vaccines are very small. I remember during the 90s, we helped Vietnam develop a vaccine industry for childhood vaccines with the Pasteur Institute. And whether we ought to be using those multinationals to produce vaccines in those countries for those countries, as opposed to worrying about the transportation issues. Dr. Schwartz, let's get back to you. You started to answer the question on the emergency use authorization.
Yes, many EUAs on medical devices. I think what I was in the middle of saying when I cut out was a fair number of them were for PPE, personal protective equipment. That's where really bulk of them were, because as you know, particularly at the beginning of the pandemic, very critical shortages in terms of the ability to provide our healthcare personnel with adequate PPE. But in addition to that, other areas where we have provided emergency use authorizations include all the diagnostic tests, ventilators, various infusion pumps. But those are probably the overall kind of genre of emergency use authorizations that we have issued. And again, it is a tool that we would pull out of our toolkit, particularly in a situation such as a pandemic, when otherwise the availability of various medical products which are necessary to be responsive during a pandemic would not be available, and to really be able to also accelerate that process.
Yeah, thank you. I yield
Does that
back.
answer?
Yes, it certainly does. Thank you very much.
Thank you.
Thanks, Donna. We'll talk to you soon. See you soon. Tom Ridge.
Dr. Schwartz, thank you. When you're taking a look at these exciting developments in medical innovation, I'm living proof that a couple of them worked. I don't get into my medical history, but thank God for them. I got it. But you take a look at the medical device itself, and you say intrinsically there are some potential vulnerabilities related to its application. Does the FDA have internally the expertise to work with the medical device manufacturer to mitigate that risk of its exploitation? And do you?
Thank you, Governor. Yeah, thank you, Governor, for that question. It's an important one. Yes, we do, but we are building, and we are further building out that internal infrastructure. It is critical that we have subject matter experts who have not only the deep domain knowledge on the biomedical engineering and the design of the device, but also the clinical expertise in terms of the device and the cybersecurity aspects of not just the device, but how the device would be potentially communicating or connecting with other systems. Now, from the earlier days, because I've been at this now for since I guess 2013, that we've really been working in very focused on cybersecurity. We've utilized also external experts to help us. We have an ongoing partnership with MITRE. And MITRE, as you know, as a federally funded development research center in FFRDC, certainly has also deep domain cybersecurity expertise and has been very supportive of our efforts. We have, though, over the past several years, continued to deepen our knowledge by bringing in and recruiting individuals. However, it's important to go back to, I think, what Mr. Ware had said earlier. We're not going to scale to the extent that we have cybersecurity experts to fill up an entire product center. So we have to be able to work collaboratively with outside experts, with other government partners, and potentially also with there are third-party laboratories, accredited labs that do this kind of work that can help with our reviewers as well in providing that degree of further evaluation and expertise. But it is I will tell you, it is a core critical aspect now of not only on the pre-market side, obviously it needs to be on the pre-market side, but also throughout the lifetime of a device. When a vulnerability is identified, it's brought to our attention. We do a thorough assessment. We work with the manufacturer as well to hear what their assessment is, to determine whether we're in agreement with their definition of whether we consider this to be a controlled or an uncontrolled vulnerability. In other words, one that the risk is not adequately mitigated and requires additional types of corrections.
Wonderful answer. I've just one final question. Are you a member of going back to Charles next, who said he was responsible for founding the BioISAC. Is the FDA a member of the BioISAC?
The BioISAC, I'm not aware of. We're certainly not our center. We're not aware of. Okay. We're involved in the HISAC, the healthcare ISAC, but not the BioISAC. Not yet, anyway.
Thank you. Mr. Frauke, I'm really interested in this BioISAC. There's a lot of, I don't mean to be quick. I'm just a couple different questions. From your perspective, the level of participation, should it expand? Where should it expand? Its level of maturity and the level of information exchange from private sector, but from the feds on down to the private sector. I didn't mean to go 1, 2, 3, but I just did. So I guess I meant to do it. Sorry about that.
No problem. Thank you for the question, Governor. So yeah, I mean, I think we need a lot more participation. I applauded during my remarks, I think, some of the nascent efforts that in particular Dr. Schwartz and FDA have done on the medical device thing. I think what's really important to note is that this is not just a medical device issue. This affects all of the bioeconomy. And so it affects CBER, it affects CDER, it affects every other office, frankly. And I think we need to bolster the capability in-house of some of the HHS agencies in particular, because it affects production systems. It affects filtration and quality checking systems that are used for drug manufacturing. And the issues there are severe, very severe, unfortunately. So I think involvement has been, so over the last, I've actually been trying to sound this alarm for about 2 years. I gave a range of meetings across USG agencies, including FDA, including FBI, and the IC, et cetera, before COVID-19 happened. And unfortunately, at the time, I'll say very openly, I made the assessment that we perhaps had 2 years to really fix this issue. And then COVID-19 happened, and it turned 2 years into a month and a half. So to your question around involvement, I think we need to work much closer together. It's been difficult to get the support of all of the levels, both federal and local, in mitigating specific issues. It's been difficult because the missions of those agencies often do not include this. We fall in the cracks often. We have had several conversations with all of the different agencies, and often what ends up happening is, well, we can't really do that, or we don't really know how to help you, or we don't really know, go and ask over there. So for the last 2 years, I've been playing a lot of ping-ponging, frankly. I think this is changing. I think there are shining lights. I mean, again, I don't mean to be a Debbie Downer here on this issue, but it's a significant challenge, and we need to change the government's attitude.
I mean, it's not a problem to be a Debbie Downer. We're talking vulnerabilities, and if there's a vulnerability in terms of the government's inability, unwillingness, or indifference to respond to what you and others see as a glaring gap in this whole biosecurity issue, you're not double downing. So what's the catalyst? Wouldn't the pandemic and the slow response and everything else have been a catalyst? You said you see that there's maybe a slight sea change. To what do you attribute the change? And perhaps more importantly, what do we need to do, or what could the commission do to accelerate the change?
Yeah, that's a great question. I do see change, although to be perfectly honest, I do not see change at the pace that matches the threat increase. We are not matching the level. And again, here in a public forum, there are a series of threats and details that I cannot speak to. But we are already our adversaries are running laps around what we're doing right now. And the pace is accelerating. So concretely, I think the commission can help create and catalyze the creation of public-private partnerships where necessary. In fact, the creation of the Bio-ISAC was in large part due to a meeting that I organized with DoD and others. We were talking about this issue, and certain DoD agencies said, look, just go and do it. So we did, and we're trying to set that up, but that's just one. We have to do a lot more training, because people like me or people like people who work for Suzanne and Dr. Schwartz at FDA, there's too few of us. There's perhaps a dozen in the country, many of them in national laboratories. In the private sector, I unfortunately am very lonely, very lonely. I think Dr. Sawaya, Sterling Sawaya is probably another person, but there's a handful of people. So we need to really improve the educational. So we need funds to develop the defensive systems. There's a question as to what would be the most effective way to do that. In my opinion, it's probably through DoD to look at the defensive systems, so that the industry can be seeded with some tools to defend itself now, and then they can catch up and continue the development. That's the most important. In the most urgent piece, the most important and urgent is we need to go and quantify these risks. If an adversary wanted today, we would not be making vaccine tomorrow. I mean, just it is that bad. So we need to really quantify the risk and figure out where the landmines are, because we've done some mapping, but we need to do a lot more. And finally, I think the commission shining a light on this is absolutely essential, and providing an expansion where necessary of the missions of the relevant agencies, so that they can actually build cybersecurity as a core competency. Without this, we are not going to succeed.
A couple more questions for you briefly, if I might. Understanding the sensitivity of the information and intelligence you have, I'm not going to ask you about attribution or accountability. That's in the hands of others, but I have a pretty good idea who you're talking about. But how knowledgeable would you say the policymakers in this country are relative to this very specific biosecurity threat? I mean, it just seems to me that this pandemic, and incidentally, our foundational document suggested that if we don't do certain things, we'll get hit with a pandemic that might cost us 100,000 lives and $1 trillion. Well, we're off by a factor of 8, 9, or 10. So we know, and this is modest, particularly with if a man-made mutation of some of these things, we know we'd have real problems in the delivery. So I understand that. How knowledgeable is the Hill and the policymakers with regard to the severity of the threat from your perspective?
Well, I have to admit a limited perspective in this, because I have interacted only in a few occasions. I will also be fair in saying this is a threat that went from 0 to 100 in no time.
It's accelerated. I understand. Yeah.
And so the result is that there are very few people who understand the totality of the threat. We have talked about today, in my opinion, about 20% of the 20% of the threat landscape, and educating the Hill on what is truly possible, because in fact, denial of a capability, of a production capability, is only the beginning, frankly, of the nightmares. And so I think we need to do a lot more education. And, you know, I'll volunteer myself to help. And I know there are others in the national lab circuits and groups that are able to do this, but we need a lot more understanding to the real threat that we are under.
Finally, and this may require you to either put some thoughts on paper, but I was intrigued by your notion that in the work you've done, which is really rather remarkable, and the small band of brothers or sisters that you pulled together to focus on this, there are some public-private partnerships you would elevate to the ideal relationship between government and the private sector, and others that you would dismiss. It sounds good, but it's not ineffective. And if you would, could you just outline for us? It probably takes too long, but I'm very interested in what has made those that are successful so appealing to you that you could draw a very clear distinction between some P3s really work well and others are named but are ineffective, probably worthless. So what are the attributes of the P3s that you look at and say, we need more of these in this space?
At the risk of being tried, the key is the human relationship. That has been the most important piece by far. We have been involved in a number of many very successful public-private partnerships, and some that frittered away. And where that happened, it was due to the departure of a key person who was pushing that mission forward. So that's been in my experience the most important piece. The second most important factor is the desire to solve the problem quickly and pragmatically in a non-academic sense. Some of these threats historically have been described in more academic settings, and they have quickly slid into very real threats, and they look a little bit different. Mr. Ware talked earlier about disinformation. I worry significantly about the combination of disinformation with some of these other threats. So the bottom line is it comes down to a good network, good relationships, which is why I was advocating for the creation of a pandemic core by ASPR. The key there is actually to forge relationships among some of those key performers and key personnel so that they can carry those relationships. We have seen in the biomanufacturing environment that often critical failures, were resolved over a beer at a conference because they shared information that perhaps they were not supposed to share, but they realized that it was an industry-wide problem. Those relationships actually are what carry it at the end of the day. And so whatever we can do to engineer those by creating cohorts and cores and educational opportunities, then I think we will have a much more resilient bioeconomy in the end.
Thank you for your service and thank you for your testimony. Very helpful. I suspect that Asher or somebody else will be following up. I'm really intrigued offline, giving us a couple, identifying specifically a couple of the P3s that work and P3s that don't work, so we could do our own examination and see what we might be able to do to apply lessons learned, both good and bad. If that's all right with you. Now let me go to Mr. Ware. First of all, I got to thank you for your tremendous work in this space. And I just want to initially thank you for the expression of concern and identifying that some of the espionage that we've seen related to the pandemic, I think we pretty well know what the sources are, creates uncertainty. The uncertainty creates distrust. The distrust pushes the government and solutions further away. And we've created we know some of our adversaries have done that within the democratic process. And now they're doing it as we try to recover from the COVID-19. So I want to thank you for that observation. But I do want to ask you, one of the concerns I've had as DHS has taken a even greater role. You talk about accelerating a role in greater and greater responsibility, is your ability to access writ large cyber experts, men and women with digital expertise, when they have the opportunity to work in the Silicon Valley or work for a high-tech company, taking all that capability and can do for themselves and their family far more in terms of the compensation than they can working with government. What's your experience on attracting and retaining the quality of men and women we need in the cyberspace writ large to support DHS and its mission across the board?
Yeah, Secretary, thank you for that question. It was probably retaining was probably the single greatest inhibitor of our success that we had at CISA. We had hundreds of vacancies and hundreds of days to fill those vacancies on average. And inside of those hundreds, the candidates don't sit there waiting in a field like cybersecurity. They take other jobs. I've had a chance to share some of my observations and thoughts with who I expect will be incoming Director Easterly, and noted that in her Senate testimony last week, she identified that hiring to be her #1 priority, and I think it has to be. And it will take more than her. It's going to take changes at OPM, changes at OMB, changes at headquarters that enable the agency to be more agile, to move faster. The thing is, I don't find the salary to be a huge obstacle to recruiting good talent, because yes, you can make more in industry, but you cannot get the experience anywhere in industry that you can get at CISA. You cannot have the amount of impact and scale and breadth and visibility that you can get at CISA. And so I'd love to see people come out of startups in Silicon Valley and spend 5 or 6 years serving in government and go back into a tech company. That'd be great for our country. It'd be great for our government, but we've got better at bringing them in quickly. And then those that are called to service and want to stay in service for 2 or 3 decades, we've got to make sure that we're training them, upskilling them, and retaining them. One thing I will say, just in the spirit of this conversation, we were granted an exceptional hiring authority under the CARES Act that allowed us to bring in to CISA people from the healthcare sector with specific experience in the healthcare sector and cybersecurity. And that process, unlike the 1-year plus process to hire normally, we were able to bring people in around 90 to 100 days. By the way, by my standards, that's still very slow, but we had flexibility in hiring that allowed us to bring them in quickly and get really good experience in medical devices with Josh Corman or other parts of. We brought in biological researchers. It was really important to us to translate what we kind of know from a cybersecurity perspective and how it needs to be heard and put to work in the healthcare sector.
Your testimony calls to mind, and something that's been on my mind for a couple of years. I have found no advocates on the Hill to pursue it. But we are in the midst of a cyber war. I mean, let's just not dumb it down. Warfare among nation states has many dimensions: air, land, sea, space, and now it's digital. And the attacks come in many different forms. We're involved and it's global, and we pretty much know who the primary adversaries are. And during World War II, we had dollar-a-year people who continue to get paid from the private sector, who to spend full time building up and then leading capacity to defeat the enemy. And I may just reach out to you because you've got more credibility in this space than I do, but the whole notion, and you just touched on it. Why? And Senator, this is something I think we ought to take a look at long-term in this space. It is almost impossible to take talented men and women who want to serve the government, who want to serve their country, out of the private sector, maintain them. And some of this is, I'm talking about incredible capabilities, keep them at the same salary, but get them into government for 3 or 4 years. There are so many regulatory obstacles to that ultimate public-private sector cohesion. It's worthy, I think, of the commission's examination, because I think just not in the biosecurity realm at large, but when your testimony, Chuck, it elevated it in my own mind, and I want to thank you. I also know what the challenges associated with CISA are, and I just want to tip my hat to your incredible service. And at some point in time,
Thank you, Governor.
Thanks. Yeah, thanks, Tom. I thought your questions were great. And of course, I'd be glad to work with you on that whole question of personnel. And I thought, Brian Ware, I thought your articulation of it was right on, which is it's more than money. I mean, it's an opportunity to be involved in the government, first to get what our old buddy McCain used to say, the special satisfaction of serving a cause larger than yourself.
amen.
But more practically speaking, you end up with an expertise that you can take back out with you into the private sector. So life comes in chapters. And anyway, I appreciate it. Jim Greenwood, are you still with us?
I am still with you. Thank you. Thank you.
Okay, it's all yours.
Thank you. And I want to follow up a good bit on what the governor was just saying. We've spent 5 or 6 hours today listening to a whole parade of horribles that have to do with cyber security in general and biocybersecurity specifically. And, you know, they range from, you know, the obvious attacks we've seen on the commercial and the attacks on government. And I think that Mr. Faki has said something that was rather sobering, which is that if somebody wanted to halt the production of COVID-19 vaccines tomorrow, they probably could. And that made me wonder if they could change the formula without the manufacturer even knowing it, so that you'd have something that's either ineffective or lethal. So and the other thing that Mr. Faki used the term dire, and he also used the phrase that the pace with which we are responding does not match the threat speed. Which is, I think, obvious. Earlier, Senator Daschle said, you know, I just don't understand why it is that when these attacks happen, these malware attacks happen and so forth, that we don't have the capacity to find the source, to track down the source. And I think we all have that same response every time one of these happens. It's, Jesus, with all the power that we have and the money that we have and the smart people we have, why is it we just can't track these people and either, you know, blow up their computers or drop a drone-fired Hellfire missile on them or something? But apparently we can't do that. We'll tell Putin, Biden will tell Putin that, you know, we're pretty darn sure that this stuff's coming from you, and I'm sure he'll be more specific than that. But even, you know, if this is the thing, and, you know, we're still nibbling around the edges in terms of response capacity and time, you know, and we're moving at a snail's pace compared to the threat. The question is, I mean, do we need to take this to an entirely different level? A Manhattan Project, a warp speeds project, where we say there are a few threats that are more fast-moving, dangerous to the globe than this one, and we're not up to it by orders of magnitude, and we need to have some kind of a mechanism very quickly where most of the bureaucratic rules just do not apply, and the money has to be there, and whether it's, you know, bringing in volunteers for free, you know, combining with the private sector, hackers from Hackathon, all of that. It just seems to me that we still don't. I saw that President Biden says, you know, we're going to get serious about responding to this, which is great, but it doesn't seem to me that our response is anywhere near the magnitude and the urgency and the awareness among the members of Congress, et cetera, that we got to do something huge and something fast, so that I think it would seem to me, knowing very little about this, that being able to figure out the source of these attacks and be able to respond almost instantaneously seems to be the magic bullet here. So what do you think?
Well, I just want to say one thing, Representative Greenwood, and then unfortunately I have to leave. I will say we can do a lot more attribution than we do. For the most part, we know exactly who is responsible. It may not always suit our interests to tell them how we know, but we know with high confidence in almost every case. There are increasing cases where adversaries use each other's infrastructure so that they look like it's coming from China when it might be coming from somewhere else, or vice versa. And we're seeing cases where our adversaries are supporting each other and sharing each other's tools and infrastructure because they have a common rival.
If I may, does that apply to the criminal malware enterprises as well as state funded?
We know exactly who they are, and we know exactly where they are.
We know exactly where they are.
We know exactly where they are, but sir, we lack tools, legal frameworks to respond to them appropriately. We have, if we wanted to respond to them from a law enforcement perspective, then we need to be able to press charges and extradition. For us to issue our charges that Russia's not going to honor, it doesn't do a whole lot. It might restrict their freedom of movement. It may limit their ability to take their ill-gotten gains and vacation in the south of France, but it barely impedes them in any real ways. We have to approach this from President Biden all the way down. We have to approach it on a diplomatic level, on law enforcement levels. We need our allies with us. And I don't think there has been an appetite yet to use military and intelligence community resources for what have been seen as law enforcement matters. But I would say we treated a non-state actor in ISIS not like a criminal element, but like a rival and like an adversary. And we've used military and IC assets on the war on drugs and cartels for decades. This has to, we need leadership here. We cannot just defend our way out of sophisticated nation state adversaries. We have to impose costs on them. And we have to be willing to impose costs, and we have to communicate that very clearly and set a new set of norms. So that's my.
Hey, Brian, thank you. I think we got to let you go, but Asha, I want to suggest that we bring Brian Ware back for a meeting. It doesn't have to be a public meeting. And I want to leave you with a little homework if I can.
Yes,
and it's important. So if you can really just write a quick memo on it. My question from this day is the cyberbio-security threat different from the cybersecurity threat? In other words, is it unique, and does it require a unique response? Or if we deal with the overall cybersecurity threat, will we also be dealing with the cyberbiosecurity threat? You don't have to say anything now, but I really appreciate what you said. If we knew where a hostile actor was, just the way we knew where Soleimani was, or Osama bin Laden, wouldn't it make sense from our national interest to hit that dwelling or building where that person was? Because we can do it. Okay, Godspeed. Thank you.
I want to come back and talk to you about that. Thank you for the opportunity, sir.
Thank you.
And Senator, I'm hoping that Mr. Frocki can answer my question when he gets an opportunity.
Yes, go ahead. Sure.
Yeah, I want to footstop what Brian Ware said, because this is 100% right from my perspective, because I am in the industry. I see that we are not spending the right amount of effort and money in order to build even the basic defensive mechanisms. So while what Mr. Ware said is 100% right, I do think that we must look at creating layers of defenses and look at things that we have seen from the supply chain environment, like concepts like zero trust and other environments must be ported to digital biosecurity. It's absolutely essential. So we must spend that so that we can do defense by denial, basically. Make it harder Because today, frankly, the expertise required, in my opinion, it's more than my opinion, my knowledge, is it takes an undergrad biologist level knowledge to do certain things, and undergrad or even less level cybersecurity. If you start pairing these people together, a lot of bad things start happening. We have seen in certain environments that even with little to no preparation, absolutely devastating impacts can be made. In some of those cases, we were able to catch them in time and try to build compensating controls. But the bottom line is that we're not doing enough deterrence by denial. It is way too easy to attack the biological infrastructure.
Thank you. Thank you.
And to Senator Lieberman's question, is cyberbio-security different from cybersecurity? I will just answer very succinctly, yes, extremely so. This is not the right setting to talk about exactly how they are different, but therein lies the exponential threat and the one that we must respond to. There is a lot of cyber hygiene that needs to be done in the bio industry, don't get me wrong, but that will not solve the problem. That won't be sufficient. It is necessary, but not sufficient to solve the problem.
We probably should bring this to a conclusion. I mean, it's just down to this band of three of us, Tom and Jim and me. Do either of you have anything else you'd like to say?
Yeah, you know what? This has been such a fascinating, I don't have anything else to say, but you know, I think if the three would be willing to come back for non-recorded, just kind of that kind of formal conversation, leave it up to them if they've got the time. We could
right.
together. I think would be very helpful. I'm just intrigued. This has been the whole been beyond sobering. It's alarming, but I appreciate the perspective, particularly the integration of these three perspectives. And I think we ought to bring them back if they don't mind sometime in the next couple of months.
Yeah, I agree with you, Tom, and leave it to Asha, but that could be either at our meeting in August, I guess, or I suppose we could convene for a Zoom meeting, which would be private and not public. My conclusion from today is that we have a real responsibility here as a commission to take what we've heard and learned and try to make at least to sound the alarm again to the executive and legislative branches of our federal government that this is a real threat, and they shouldn't be passive about it the way, frankly, they were in response to the threat of an infectious disease pandemic. They should act before something happens. Jim, do you want to say a last word?
Thank you. Thanks so much to all of the panelists here with us right now. It's just been fascinating, and I would certainly love to join any further discussions with any and all of you.